Let's start. Let's welcome our first speaker, Adam. He is software development engineer, public speaker, writer, blogger, and scientist. Wow. He will be presenting on the missing chapter in your CI playbook, database guardrails. In his talk, Adam will share his insights on how to ensure that ORM-generated SQL queries are safe to run in production. Hi, Adam. Please start.
Hey, everyone. Thank you for introducing me. I'll just now capture the screen and start sharing my slides. Hope you can see that all. And hello, everyone. I'm a software engineer working with Mattis currently, and we wanted to share a little bit of expertise, how to construct the CI/CD pipeline, how to introduce database guardrails, and how to improve our deployment process to make sure that all we do is actually going to work well in production. Because as we know from our experience, as we know from empiria, from practice, it's pretty often the case that when we develop something, we do not necessarily know whether it's going to scale out well, work well in production once we deploy there. So what we want to do is we would like to make sure that whatever we do is actually going to be very solid and won't fail once we deploy on Friday afternoon, right? So in the next 40 minutes, what we are going to do is we are going to see which things may go wrong and how to prevent that, how to prevent bad code from reaching production, and how to make sure that our CI/CD pipeline and everything around our software life cycle is of top-notch quality. So the very first thing we want to stress is we always, as software engineers, we need to be proactive and we need to push to the left. We can't let ourselves just deploy the application to production without making sure, without testing whether it works properly, whether it works well. We need to test our application. We need to make sure that whatever we develop is of a high quality. And we need to do that as early as possible. We can't wait with these tests until load tests. We can't wait until the very end of our pipeline. What we need to do is we need to make sure that everything works well right when we are typing the code, right when we are implementing the app code of our application, right? So what we are going to do is we want to push these checks, automated tests, QA, whatever else, to the left in our pipeline to happen as early as possible. The other thing we need to do is things will go wrong anyway. No matter how hard we work on deploying things, how hard we work on making sure that whatever we deploy is of the highest possible quality, things will break in production. Why? Because of different data, because of different data distribution, data volume, because of different traffic coming over weekend compared to weekdays. So whenever something goes wrong, we need to find the root cause automatically. We need to have as much details as possible to identify where the problem is without learning all about the ecosystem, right? What we want to do is we want to have everything at our hands, everything about the database, about our application, about configuration, running config, scalability, environment variables, whatnot. We want to have all of that combined together so that we can identify and find the root cause as early as possible and us automatically as possible. This is a must-have for every business, not for big companies, Fortune 500 enterprises, nothing like this. This is for small companies, for startups. This is for big companies as well. This is must-have for us as software engineers today. So before actually moving on, how do we actually make sure that whatever we do is going to work well in production, right? Everyone tells us, hey, we need to deploy often. We need to deploy continuously every single day. How do we make sure that things that we deploy are going to work well? But more importantly, how can we figure out what can even go wrong, right? And there are various areas of in our software engineering that may go wrong. Starting with the deployment may break, right? We have multiple platforms, typically Windows, Linux, ZOS. We may have mobile devices, IoT devices. We have hardware platforms, software platforms. Things differ between those. Sure, we can test some of the things locally. We can test things in our local staging environments, etc., etc. But ultimately, what happens is there are differences between our environment where we implement stuff and the environment to which we deploy. Differences like even very silly things, like for instance, the directory separator, right? Slash versus backslash, right? New line ending or whatever. But even bigger differences, for instance, how operations are implemented behind the scenes. For instance, Git is very bad on Windows because Git uses completely different IO operations that are unfortunately not very well optimized on Windows, or at least used to be not very well optimized, but they were very fast in Linux. So those things may differ between our platforms. Not to mention things like permissions, like IAM roles, like things in our cloud environments, like on-prem environments, connection strings, environment variables, all the other stuff that needs to be deployed successfully to production for our application to work. It's pretty often the case that, hey, we deploy something, it worked well, like flawlessly in staging, but once we deployed to production, we learned that, hey, we didn't deploy like environment variables, right? Or we didn't deploy all the settings for Docker containers, right? We don't have proper like memory settings, CPU settings, and other stuff, right? These things may just break when deploying to production, and we need to identify and test all of them before moving on. That's first area. The other area we have is our code may break. As simple as that, our code may contain bugs that were just not captured during like system testing. But also our code may have some inherent like dependencies on the locale, on the environment that we are working in. For instance, already mentioned like line endings and other stuff, right? But those are the things that we are pretty often used to. We kind of know how to identify them, how to test them, especially if we can mirror production environment in our like dev staging environment. So those things are cool. However, our code may face completely different conditions under which it is running. For instance, different traffic, different data distribution. We tested our stuff with like US database, but then we deploy to tiny country in Europe and bang, we get completely different data traffic, which our code just cannot handle. We have this phenomena of like works on my machine, but once we deploy somewhere else, it just doesn't work and we have no idea why, right? We need to figure out how it goes. And finally, the very last thing is increased load and scalability. Like it is easy to test our application locally when we have like 10 rows in our database and everything is going to work well. But in production, we'll face completely different traffic that depends on like time of day, time of week. You have different peak hours depending on the business you're running. If you run like e-commerce application, you'll probably get much more traffic like near Christmas or near Halloween, right? If you're running like a ticketing system, then probably people will buy tickets like early in the morning or right after coming back from the office because of how they commute to work and come back home, right? We may get completely different traffic when we run like a streaming application for videos, because then people will most likely watch stuff like in the evening or during weekend, right? So this changes how we can test our application. If we are testing that only like at this very specific hours, the same time every week, then we may miss different traffic distribution, different traffic load, traffic coming from different countries, from different segments of our users. All those things are very hard to test like in our pipeline, just because, well, we would basically need to run another production. And running another production is like very hard from technical standpoint, very expensive, and most importantly, it takes time. So we see that for like 3 different areas of how we deal or what can go wrong with our application. And whenever we think about, okay, how do I make sure that whatever I deploy is going to work well in production, they tell us CI/CD is the answer. I know CI/CD, I know how to do the stuff, right? Well, CI/CD stands for 3 different things. First concept is continuous integration, CI for sure. What we want to do is we want to merge our branches into main branch. We want to compile the application, run all automated tests, unit tests, integration tests, you name it, run them locally to make sure that what we built is actually going to work well. We have all the dependencies, we have all the libraries in place, code is there, and basically code works on the critical paths that we identified. Next thing we want to do is continuous delivery, CD for sure. What we want to do is we take the package that we just built, we've just tested, we deploy it to all the non-production environments just to keep everything in sync. Our developer environments, QA environments, staging, pre-production environments, all of them should be running exactly the same code, should run exactly the same tests, so we can see how it works and we can be consistent across our company, right? But then we have continuous deployment. Continuous deployment is when we take the package and push it to production automatically, right? Technically, this is very straightforward. We just deploy to a yet another environment. However, there are various things around that that may make it much harder. Those things are, for instance, we probably don't want to deploy during peak hours, right? Deployment may take time. Even migrating the database may take like minutes or even hours. We have completely different traffic distribution. We have caches that may be flushed. Generally, tons of things we need to take into consideration when deploying automatically to production, and especially when we are talking about how do we make sure that our application is going to work well, right? So those are the things that we need to be aware of. And let's now dig a little bit deeper into what can actually go wrong when we are talking about like CI/CD pipeline and databases, right? So we'll cover issues with databases, with ORMs, and the most important issue, which is lack of context when something goes wrong. So we'll go through these 3 different areas to see which things we may face, and later on we will see how to fix them and how to make sure that we do not make any silly issues. So the first thing is problems with databases, right? We use SQL databases, NoSQL databases. Generally, we have some data storage that is backing and powering our application, right? Whenever we talk about databases, we can group issues with them into like 3 high-level areas where things may go wrong. Very first thing is code changes, right? So we change our application code. We change the code, which in turn generates different SQL queries or different queries to our database. Those queries, because they are now different, they have completely different characteristics, right? They extract different data, access different tables, different columns, and obviously have different performance. So this is the very first thing. We typically test this area using unit tests. We make sure that what we generate is actually doing the right business logic, right? So this is kind of covered. The other thing which may go wrong or which may cause some issues is schema changes. Basically, running any schema migrations that we may have, adding new table, adding new column, changing column type, configuring indexes, changing view definitions, stored procedures, functions, you name it, and whatnot. And generally, those things that are very straightforward to test, because like if we screw up the schema migration in our application, then we immediately see what is wrong, because like the column doesn't exist and we get weird errors from our database engine, right? But there are 2 different things that we typically miss when we're talking about testing. First thing is those migrations, they take time. Adding a new column type or a new column to a table may take like split second, but if we need to rewrite the column, then this may take like minutes or even hours in a heavy loaded and very occupied system. Same goes for adding indexes or rebuilding indexes. These things may take time and we just can't take that locally. Why? Because when we take things, test things locally, what happens is we have like 100 rows in our database. We have very scarce number of like entities that we could run against, or we could run against migrations, those against the data, right? So what we don't see is how this thing is going to work when we have plenty of data in our production database. So once we started the deployment, it may take way longer than we expected, and we won't catch that typically with our CI/CD. The next thing is query changes, how it executes. We are not talking here about the query text. We are not talking about changing the query that we run. No, we're talking about we have the same SQL statement that we run over and over again for days, weeks, or months. But now, because of different data volume, because different indexes, different configuration on tables, we get completely different execution plan. And effectively, the query works differently, works way slower, or extracts data in different way. Again, something that we won't spot when we are talking about testing environments, but something that would hit us the very first second we go to production. So let's see what can go wrong. For instance, talking about slow queries. This is actually an example from one of my production systems. So imagine that we have this big aggregate root. And what we want to do is we want to get the user entity. And this user entity has multiple tables that we would like to include, like details, pages, text, reports, whatever else. When we implement like an application code like this, what happens behind the scenes, our ORM will generate the select statement like this. So select with multiple joins, right? And this thingy resulted in, just for one aggregate root, resulted in getting around 300,000 rows. And ultimately, those 300,000 rows were returned to the ORM and then processed by the application by something like 25 seconds. The application code. Why is that the issue? Well, the issue started because we have these multiple joins, and because whenever we join rows, we join tables, what happens is we have many more things that basically exponentially increase the number of rows we get. So this results in 300,000 rows being delivered to the ORM, something we won't capture at all when testing things locally, when we have basically like 100 rows in our database, right? We won't see this exponential increase. We won't see those Cartesian products happening behind the scenes because we just don't have enough data. How can we fix that? Well, in order to fix that, at least in this case, the solution was to split this aggregate root into multiple different queries. So get all the components of this aggregate root like independently, effectively running multiple independent select statements to our database, and then combining all of that in the application code. Even though we were running many more SQL statements, all of that executed in like less than a second, in split second, just because we were getting much fewer rows to our application. So it's not as clear that, hey, the more the queries you have, the bigger the problem is. No, that's not the case. In this case, sending more queries was actually improving the performance, something we wouldn't catch in tests, right? Something that we would see only in the production. But the other thing with database and queries is queries can be equivalent, but have completely different performance characteristics. For instance, take this. I have boarding passes table with something like 8 million rows, and I sent two handcrafted, obviously, queries that do exactly the same. First query uses common table expression, kind of like a synonym for temporal table, in which I take the ticket number and I calculate a hash twice using MD5. Right? Then what I do is I join these tables like this temporal tables 3 times and get the rows for very known like hash ID or hash number for this ticket number, right? And this thingy executes in 13 seconds, right? The other query that we can run is equivalent. This is exactly the same query returning the same data. The only difference is now it injects like this MD5 hashing 3 times in this where condition instead of preparing like this temporal table, which is CTE here. But this thing runs in 8 seconds total, okay? So what we see here is you get the equivalent query. So your ORM, your library may generate either of these queries, and you can see that they will give you exactly the same result, but you will get completely different characteristics. Still, something that you won't spot easily with like unit tests because, hey, the result is the same. You get exactly the same output. However, if you have only 100 of rows in your database, you won't see the performance issues. To get the performance issues, you need to either go with big load tests, which are heavy, take much time, and are very expensive, or you deploy to production, and that's when you learn about that stuff, right? Again, same issue that we can't easily catch very early in our pipeline. Another thing is something I already mentioned, incompatible changes in schema, right? Adding a column, that might be a problem when you go with select star. It may cause like table rewriting, reorganization of the table, index rebuilding, just because you added new column that must be somewhere in the middle. And because you have like clustered index, you need to have rows ordered like on physical drive. So you need to rewrite whole table, right? Dropping a column, this is very dangerous because depending how you run the deployment or whether you have heterogeneous applications or not, you may get completely different errors than when you run things locally. Why? When you run things locally, you typically run things only like on single node. You do not scale out your application locally, right? But once you go to production, you may have multiple nodes running your application. Now, if you can do the deployment atomically, meaning that you can deploy a completely separate fleet on the side and then atomically swap like load balancer to hit the new fleet, then it's all good. But if you are replacing hosts one by one, then at some point you end up with things that we call split blame. Half of your fleet is running with the new code, the other half of your fleet is not running the latest code, is running with the older version of the code, which means that, hey, you basically expect completely different schema in the database. If you do not have migrations that are backwards compatible, then you end up with issues that your old version of application will just simply fail. Similar case is when you have heterogeneous scenarios. So when you have multiple applications running against the same data store. So the other application may not have the schema updated yet, and you end up with issues because, hey, the column is not existing anymore, right? So this is the issue with schema migrations and other stuff that may actually break the applications like in place. The other problem with schema migrations is just the performance. Rewriting the table may take minutes or even hours. Do you want to take your application down just to deploy the latest version? And if you do want to take it down, maybe you need to take it down, then how do you make sure that your clients and your customers are not affected? How do you deploy this? Do you do it at night, etc.? Generally, various things that you need to be aware of and are very hard to be tested like in your local environment. Missing indexes, yet another case of database issues. Like whatever happens when it comes to performance, people tell you, hey, you should have an index. If you add an index, obviously your reading improves, you have selects running much faster, but at the same time, your updates are way slower because now you have multiple data structures to be updated. And the thing with indexes is when a junior developer learns how to improve the database performance, that adding an index is a solution, what we end up with is too many indexes in our database. So we have way too many indexes. We index all the things. SQL, like select statements are faster now, but update, delete, and insert statements are much slower because we have many more data structures to be modified. But the other thing which is also important here is that indexes degrade over time. Maybe we added an index like half a year back that was helpful back then, but now because we changed our application logic, that index isn't used anymore and it's only decreasing the performance. How do we identify that? How do we see that when we talk about like continuous integration, CI/CD? How do we check that when we run things locally? We need to have this monitoring capability that will tell us, hey, this index that was useful half a year ago is not useful, not being used anymore. So it should be dropped. So those are the things that we have databases. And finally, the other issue we may have is bugs. So obviously, some of the bugs we may capture pretty easily with like unit tests, integration tests, but there are also bugs that are manifest themselves only because of the database engine we use. One of them is, for instance, Halloween problem. It takes its name because it was identified on Halloween. If you run a query like this, unpaid employees, and increase the salary of the employees by 10% for all the employees that earn less than 10,000, right? What can happen and what actually happened is that this query updated a row, increased the salary, and because the salary after the update, after the 10% increase was still below 10,000, the same entity was updated again and over again until finally all the entities, all the employees got 10,000, at least 10,000 of their salary. Right? This is the issue with your database engine, something that you may miss when you run things locally because database issues or engine issues are probably very edge cases that are not very easy to be reproduced like in your testing environment. So generally, testing all that stuff is hard, and we need to be aware of what may go wrong. But when talking about completely different area now, we typically interact with our databases using ORMs. ORMs, so object relational mappers, what they do is they allow us or they let us write a little bit of application code in JavaScript, Python, C#, whatever language of your choice is, and then they translate the query to a SQL statement behind the scenes. So let's take the example of n+1 select problem. Imagine that you have a table called aircrafts that have basically airplanes, and there is in relation one-to-many with seats, basically because every aircraft may have multiple seats. So we would like to get all the aircrafts, and then for each aircraft, we would like to get like the number of seats it has, right? What may happen is this results in n+1 queries, because first query is for getting all the aircrafts from the database. And then for each aircraft, we send another query to get the seats from the table. So in total, we have one query for the aircrafts and n queries for every aircraft individually, which takes n+1 queries in total. Obviously, the more aircraft you have, the bigger the issue is. It can be solved by running one query to get all the data together with a simple join. However, how do we instruct our ORM to send one query instead of many queries? We need to go and change the something like global configuration of our ORM. Definitely something that is not near the application code we implement. So the moment we implement this application code, we don't see that there is an issue. And this global configuration may affect other things. For instance, the issue we have already seen. If I take the application code that like does this many joins and I want to go eagerly and join all the tables together at once, then we've already seen that this is an issue. So for some cases, we would like to run the join. For some other cases, we may want to run this in a lazy fashion. So basically to get this n+1 problem like purposefully. For some other things, we may even want to restructure the way we get the data. ORM is not a silver bullet. ORM hides the complexity behind the scenes, but does not solve our issues automatically. We need to see, we need to peek behind the scenes what's going on and understand what is the implication of what we implement. The other thing we have is the so-called impedance mismatch. The impedance mismatch, which manifests themselves in like two different things. One idea is how do we represent object-oriented hierarchies in our ORM in our database? How do we basically get the polymorphism in place into our database? There are various solutions, various approaches like table per hierarchy, table per type, etc., etc. But now we need to ask ourselves a very important question. Should I start with defining my model in the application code? Or maybe should I start with the database and then structure my application code to resemble the data storage? None of these solutions is better than the other. Both of them have multiple issues. But generally, the outcome is if we make the wrong choices, then our model on whichever side is going to be inefficient, meaning that it's either the object-oriented model that we have that does not work well with object-oriented logic we want to run, or the database needs to do tons of work to represent all the object-oriented things we wanted to have in our language. So generally, no, it's not a silver bullet. There is not a simple solution that we could go because it all takes some pros and cons, and we need to understand what we are doing. The other thing when it comes to impedance mismatch is data types. Simple as that. How do we represent a thing that is common in SQL engines? That is spatial data. Spatial data, so basically coordinates on the globe where something is, like GPS coordinates, right? Some ORMs will be able to represent that using native SQL data types. Some ORMs will need to serialize that to string or pair of numbers, right? Same goes for other things, for instance, binary data. But things get even more interesting when it comes to even strings. Like in databases, you have a thing that we typically call varchar, like variable character length. However, we also have a thing that is called collation. Collation defines the order of characters. For instance, it can dictate that when you compare two different strings, you should ignore the casing. And the uppercase character should be equal to the lowercase character, right? Or maybe the opposite, they should be treated differently. It can dictate which character is lower than which one. So for instance, you can change the order of your alphabet using collation, right? How do you do all of that with strings in the language of your choice? Can you change the implementation of string in, I don't know, Java, JavaScript, Python? You can't. And because of that, you can't represent collation properly, and you need to do quite a lot of logic that like basically leaks between those two layers, between data layer and your OOP layer. Same goes for numbers. How do you specify decimals like numbers from database with different precision? We typically can go with like float or double in our language, but we can't specify exactly what the precision should be, but we can do that in the database engine. What this is gets even more tricky when we run heterogeneous ecosystem. So we have one data storage that is accessed by multiple applications written in different technologies, one of them being .NET, other of them being Go, yet another being Rust. How do we represent the same data in those various applications without hitting the impedance mismatch problem? This gets even more trickier when we increase the complexity of our system. ORMs pose even more challenges. I will just list some of them and briefly mention them. For instance, transaction isolation level. Do you know what your isolation level is? Whether it's serializable or read committed? Do you know that in read committed, which is, by the way, the default for most of the databases, do you know that it is allowed to skip some row or get duplicates when you run select statement? This is perfectly fine according to the standard. Do you know who starts the transaction, who commits it, who rollbacks it, when does it terminate, and how? Do you know who controls the errors handling? What about caching, especially when you have multiple nodes running in your application? Do you cache data in the ORM, or maybe do you go to the database every single time? Do you create new connection? Do you have connection pooling? What do you do when you run in like Azure Functions or AWS Lambda? Who holds this connection pool, when it's by being like rolled, recycled, etc., etc.? What about query hints? How do you know whether you can specify the query hints? How do you even know whether the query hint is still usable and actually increases the performance? So ORMs, they also improve like or break things in migrations. What about databases? How do you know who controls tables in your database? Is it Flyway? Is it Liquibase? Or maybe it's your ORM? What if your ORM figures out that there is some like drift between your database and your application code? Is ORM going to fix that automatically? Some ORMs will do that, but do you want that? How do you roll back? How do you roll things forward? How do you keep compatibility? And more and more and more. Generally, ORMs are cool, but they scatter the configuration in so many places that it's very hard to understand what's going on. There are multiple moving pieces, multiple problems with like views, stored procedures, isolation levels, etc., etc. So ORMs, even though they are great, it's very hard to understand what they actually do without seeing everything behind the scenes. And that's the important part. We want to see everything that goes under the hood. We need to have the context and we need to understand everything to automatically troubleshoot and to find the root cause of all the stuff. So now let's see, how can we do things better nowadays using modern standards, modern approaches, and how can we do things that we call database guardrails to make sure that our things work well? The very first thing to understand is if we want to fix databases and deal with scaling databases and whatnot, we need to understand how they work behind the scenes. The very first thing that we typically get is the execution plan. Whenever you send a query to a database, this query goes through various stages handled by your database engine. First stage is parsing. Database engine parses the query text and creates something that we call abstract syntax tree, AST for short. Then this AST is being rewritten into some standardized form. Why? Because some queries are equivalent even though they have completely different like SQL text. For instance, you can use different aliases or different order of columns or whatever, but ultimately these things are equivalent behind the scenes. Then comes the third important part, which is called planning. There is a part in your SQL engine that is called planner that takes the query and tries to figure out, okay, how do I get the answer for the query I got? How do I find the data? And planning is a very sophisticated process of identifying what your data is, how to join tables, how to use indexes, which indexes to use and whatnot, basically to figure out how to do it in the most efficient way. And finally, the query is executed by the executor. So let's focus on the planning. What can we do with the plans? Whenever we send a query, for instance, in PostgreSQL, we can add the explain. And explain tells the engine, hey, do not execute this query, but tell me how you would execute this query. And what we get in return is the execution plan. The execution plan is basically a big data explaining what's going on behind the scenes. It consists of things that we call nodes. Every node in this plan, more or less every node, is basically a node. And node can be of multiple types. For instance, node can represent an operation in the database. For instance, scanning the table, or scanning the index, or ordering things, or joining tables, or hashing, or other stuff that database needs to do in order to give you the answer. But the other thing that every node has is the cost. Cost is basically an arbitrary number that doesn't have any meaning when it comes to like either number of IO operations or whatnot, but it's basically a number that allows us to compare different execution plans, because the lower the cost is, the cheaper and the faster to execute the query is. So we want to find the plan that has the lowest possible cost. And cost is more or less correlated with the number of IO operations we execute. So how hard it is to bring the data from the drive to the SQL engine and process it. How many times we need to spill the data to the disk, how many times we can use caches, memory caches, or whatever. So this is basically how we get the cost. And the idea is that your SQL engine runs this, creates multiple plans, and calculates the cost for each plan, and then chooses the cheapest plan to execute the query. So this is how we could reason about whether our ORM code, or the code that, or the queries that ORM generated, whether it's going to work well, is going to scale well in the production, by looking at the execution plan. But how do we get the execution plan? And now the trick is we can use the OpenTelemetry. OpenTelemetry is basically a modern standard provided by CNCF, so Cloud Native Computing Foundation, that allows us to instrument our application on multiple layers like HTTP, ORM, SQL driver, whatever else, and extract things that we call signals, and those are logs, traces, and metrics. OpenTelemetry, OTEL for short, is basically a set of SDKs for various languages, C++, PHP, JavaScript, Python, Java, C#, whatever else, SDKs that allow you to get those signals from your application, so traces, metrics, logs, etc.
Let's quickly recap what I was covering. So OpenTelemetry allows us to basically, it's an SDK that gives us the ability to instrument our application on multiple layers. And we want to get signals, traces, metrics, logs, whatever else. The way it works is when we have a distributed system, what happens is we can control and trace how the requests are going throughout our system. Let's say that our user hits the node A, which is like load balancer, and then load balancer needs to code the application, needs to code the database and other nodes like behind the scenes, okay? What happens is this whole operation of calling all of that is basically called a trace, and the trace represents some workflow that was executed in time. And the interaction between the nodes is called span. So we can get span for every operation that was happening behind the scenes. And we can get human-friendly details of what was going on, the name, timestamps, etc., etc. So this is how we run observability and monitoring today in today's modern world. Now, how can we use both of these things, the execution plans of SQL query and the OpenTelemetry spans, to tell confidently whether our application is going to work well in production? Well, we could run load tests. We could run big load tests on our application, see how things perform, what they do behind the scenes, get the OpenTelemetry spans, and reason on that. But the problem is load testings are very late in the pipeline. Very late, meaning that we need to run them only after we're done with implementing our application code. And we can't wait for that. We can't wait for load tests to identify issues and to learn that our application is not going to work well. Load tests are slow, expensive, and way too late in the pipeline. We need to push things to the left and do them as early as possible. And how can we do that? Metis comes to the rescue. So Metis is basically a software as a service that uses OpenTelemetry and uses execution plans from the database to give us this fancy experience of identifying everything that happens and whether it's going to scale well or not. So it gives source code integration, pull request analysis, and other things. So let's see a very quick demo of what's going on. So when you integrate your application with Metis, which takes basically OpenTelemetry that you already have in your applications nowadays, what you can get is you can get a tracing of everything that happens like in your test, during your implementation or whatnot. And this tracing gives us something like this, for instance, that, hey, our application exposes this REST endpoint. When someone coded, they got HTTP 200 in response. But more importantly, those are the SQL statements that were triggered against the database. If we want to understand those SQL statements, then sure, we can get the SQL, like a SQL statement text. We can get some metrics. We can get visualization of the query to see all the details of what was going on, what was the cost, etc. But most importantly, for us developers, we get automated insights telling us, hey, this thingy is not going to work well in production. There is some critical issue here. And this is the impact of this query. And this is how we fix this query, how we make it better. So we get automated insight right at our hands just when we are implementing the application. So this is all we get when we drop one dependency to our product, to our app, and we integrate OpenTelemetry. But that's not the end of the story. What we can also get is we can, for instance, integrate that with CI/CD. For instance, we integrate that with GitHub Actions, and what happens is whenever we have a pull request, we can, for instance, automatically analyze the queries coming from that pull request. So now when you do the diff, when you review the code someone else wrote, you can see not only the changes in application code, but also how it actually performs in the production. The other thing that comes is how do we take all of that from local and give the observability for the production environment. So we run a very tiny open source Docker alongside our production database. And for instance, we get automated analysis of our database. For instance, telling us that, hey, there is a table that is called booking flights that has like critical issues because it doesn't have indexes on it, right? Or the other thing is you may get observability dashboard with all the details of what's going on, how it's running behind the scenes, like the slowest queries, extensions, etc., etc. But more importantly, for instance, hey, you have indexes on your database configured, but it seems like this index hasn't been used for the last 2 weeks. So we can immediately see how your performance degraded over time. And the important part is Metis doesn't want to put you like or show you metrics, CPU spiked or memory increased. No, Metis doesn't expect you to put thresholds on the stuff. Metis tells you exactly what you need to do, how to do that, and in the future even submit an automated pull request to your code base, for instance, to modify your ORM configuration to increase the performance. So this is the idea that we get, right? And we get all of that just by using open standards like OpenTelemetry and open source solution. So coming back to the slides, Metis integrates with your code, whatever language you use, whatever database you have, whatever ORM, HTTP server, etc. you have. So to instrument the application and get the OpenTelemetry traces and spans and execution plans from the database to tell you whether things are going to scale well in your production. It integrates with your CI/CD pipeline so that it covers you when you just implement the code, and when the pull request is created, it can immediately tell you that, hey, this thing is not going to scale well in production. You don't need to wait for the load tests to be executed or even for the deployment just to see that, hey, this thing is not going to work well. It gives you full observability of everything you have, like your database, your performance. You can use it with CLI tools, you can use it with ad hoc queries, etc., etc., and it protects your database from breaking, from bugs, from ORM issues that we have, and from load tests that are very expensive, very heavy, and run way too late. Metis covers all of you need to make sure that you have proper database guardrails in your CI/CD pipeline, and that you can run all of that as early as possible and push to the left. So being all of that said, I would like to thank you for listening to this talk, and now it starts the Q&A session. So if you do have any questions, I'm happy to take them and answer.
Thanks a lot, Adam. That was really interesting. I really like the energy you were presented your lecture in. And I can see that there are some of interesting questions, and let's pick up the most interesting ones and try to answer them.
Okay, so let's go from top to bottom.
Thank you, Adam. So let's maybe answer for the first questions. What are some common mistakes or pitfalls to avoid when implementing CI/CD, and how can they be avoided? Maybe related to the database that you're talking about.
Yeah, and the most important part from my experience when it comes to CI/CD is that we test stuff using mocks and not in the infrastructure we are dealing with. So the problem is when you run things locally and run all the tests, unit tests, integration tests, whatever, and you use database that you think is the proper one, but it's like H2 in-memory database, then you're not running the stuff you want to run. Because later on you deploy the stuff to production and then you have like Oracle database, completely different license, completely different configuration. So your CI/CD and basically your process tells you that, hey, all is good. But when you go to production, then you realize that because of some quirks of different infrastructure, you get completely different results. So the biggest issue I would point is not using the same components locally as you run in production. You can fix that, or you can help that a little bit by using infrastructure as code and by running basically the same environment, using the same like cloud components, the same license, etc., etc. But generally, this is pretty often hard thing because you may not have money or not be allowed to run database with the same license as you run in production, right? You may not even have the access to the same hardware, right? What if you run on an IoT device that you just can't run locally, right? So all those things, I'm not saying that it's simple to be solved. It's not. And actually, I have a different talk you can find on YouTube how to actually do testing with those conditions, under those conditions. But generally, whenever you run load tests or whenever you run CI/CD in your pipeline, strive for having exactly the same environment. Otherwise, you'll run into weird issues later on.
Yeah. Thank you for this answer. The second question is, why is Metis better than native database optimization tools?
That is a fantastic question. Native database optimization tools, they have two issues, or they do not cover two things that Metis does. First thing is they are very database centric, meaning that they do not know what your process is. They do not know when you were deploying stuff. They do not know what libraries you use or what configuration of caching you have around, right? They are great when it comes to improving, like tuning your index or suggesting your index, but they do not know everything around. That's the very first thing. Second thing, those things, those tools, they pretty often give you the numbers based on the characteristic of like performance you observe. So they give you, hey, this is the CPU spike, this is the IO spike, memory spike, but you do not understand whether this memory spike is because of you have wrong configuration in your ORM, your application, or maybe in your auto vacuum in database, right? You need to have this holistic approach to connect all the dots together. So we are not trying to necessarily replace the tools of your database. They are cool and they solve very specific use cases. However, they do not give you the broad context of everything around. And Metis does you exactly that. It gives you those automated insights that take into consideration multiple things of your CI/CD, application characteristic, language you have, and the database you use. So they are better in the sense that you do not need to come up with thresholds based on the metrics you get from database, but you get actual solutions that you can just apply and you are sure they will work well.
Yeah, great. Thank you. And I think the last one question maybe, is Metis only for SQL database, or does it work with, or it works with the MongoDB, for example, or other databases?
That is a fantastic question. At this point, production support is for Postgres and MySQL. We are working on supporting MongoDB and other NoSQL, mostly document databases initially, pretty soon. So our roadmap says that this should be done, let's say 2-3 months. and then document databases will be supported. Mongo will be the very first one to support. Later on, Elasticsearch as well, and other databases of different characteristics. This also is going to be available later this year.
Great. So we have 4 minutes left. Let me ask you one more question.
Sure.
Why should we anonymize logs? What security concerns should we have in mind?
That is a very, very good question. And there are a couple answers to that. First answer is, well, you have law. You have GDPR, you have HIPAA, you have California Protection Act, you have other legislations that basically disallow running or processing data in non-production environments. So, or actually they do not disallow, but what they do is they impose tons of limitations, how you can do that, who can do that, whether it's controlled, how can we remove the data as customers and whatnot. So generally, we want to anonymize the data when taking them from production to staging, just to not need to deal with this data, with information security, with red data as it's called in some components and whatnot. So this is the very first thing. Second thing is just security. Let's face it, developer environments and non-production environments are much less protected when it comes to security and access. We know all of that. We put IAM role with access for everyone on the team to call any API in our cloud, right? If you put production data in non-production environment, you just basically ask yourself for troubles. It will be a problem that someone just takes this data and even involuntarily, but leaks it somewhere, takes a backup, puts it on some storage that is publicly exposed because we didn't secure the configuration and whatnot. So another thing is security. We just want to be careful not to put data in developer environments. And third thing is to control how we locate the data or how we store it. It's much better if we just don't have the production data locally. Why? Because then this data leaks to multiple places, to SQL database, to backup storage, to log files, to, I don't know, APIs, to screenshots, to internal Jira system or whatever. And you just see someone social security number being exposed in one of those systems. So it's much harder to do this data governance where the data is stored. It's much harder to be done when we allow for the production data to basically roam around. We would like to control that, and to do that, let's just anonymize all that stuff just to be safe and secure.
Yeah, thank you. I think we should finish. Thank you. Could you please choose the best question?
Yeah, best question. I think the best question, let's take first from the top. What are some common mistakes or pitfalls? That was actually the best question because the answer is super long. So let's pick that one.
Okay. Thank you, Adam. Thank you for sharing your thoughts with us, and we will continue. Dear guests, let's give a warm welcome to our next speaker, Alexander. He is a senior developer at Akvelon and a technology enthusiast who loves experimenting with new tools. Today, he will share his experience on choosing the right persistence for your application. He will explain database theory and various long-term persistence options. Additionally, he will offer valuable tips on how to select the most suitable solution for your project. Also, we will have hands-on session where you will work as a solution architects. So please stay tuned and welcome, Alexander.
Yeah, hello all. My name is Alexander, and today I'm going to present to you my vision about the main principles of how to choose a persistence layer for your wonderful applications. So presentation would take 50 minutes and consist of 2 halves, where first would be a shortened but required exploration with raw theory, a quick look at database types, and the assessment table at the end. I will try just to refresh your knowledge about persistence available in the wild and general paths to navigate in them. In the second half, we are going to investigate 3 examples of applications from small to medium size. And for each of these applications, we will explore some initial requirements. We will add them into persistent layer requirements and eventually reveal which persistence is most suitable for such application and what alternatives we have additionally here. So, about raw theory. I guess everyone has at least heard about ACID transactions, or ACID. It stands for atomicity, consistency, isolation, and durability. These 4 properties represents different aspects of reliability from database side. So first is atomicity, and it ensures a transaction is either fully completed or not executed at all. For instance, if we are transferring money between 2 bank accounts and we want the operation subtract amount from first account and add this amount to the second account, either succeeded together, like money will have been transferred, or do nothing, like money stays the same. Next is consistency. It ensures that the transaction starts with all database constraints satisfied and leaves it satisfied. It leaves it with satisfied constraints after the query. So nothing changes from the your schema, maybe state. Third is isolation, and it's crucial for managing concurrent transactions. It ensures that intermediate state of one transaction is invisible to another transactions. For example, in a scenario where 2 customers try to book the last available seat on a flight, isolation ensures that only one customer can eventually reserve it. And lastly, durability guarantees that once a transaction is committed, the changes are permanent, which means save it on disk, even in the case of someone accidentally pulling the plug out of the socket. It's reliable. When database is ACID compliant, it means that all these 4 properties are handled on the database level. Therefore, applications with such database may be a little simpler. The next serious thing is a CAP theorem or CAP theorem, and letters here stands for consistency, availability, and partition tolerance. The theorem itself states that it's impossible to achieve all these 3 aspects of distributed database simultaneously, and we must make trade-offs, prioritizing 2 of them and losing one of them. Yeah, let's define these terms. Then consistency means that all nodes in the system, so it's distributed, if you remember, see the same data at the same time. Availability ensures that every request made to the system receives a response, even if calling not unavailable, for example. Partition tolerance guarantees the system continues to operate despite of network failures between nodes or partitions, anything. So let's see these options. First one is CA, or consistency and availability. This model is suitable for applications where network failures are rare and consistency is crucial, like database system. Oh, sorry, database for banking systems. So in case we experience some network issue, clients just get an error and nothing happens. But it's reliable and consistent from this perspective of the application. The second option is CP, and it's prioritized partitions tolerance and consistency, but availability may suffer. This model kind of works good for applications like trading platforms. So yeah, your transaction might fail, but kind of nothing happened, and everyone on the market has the same stocks. So it works for this kind of applications. Last option is AP, is availability and partition tolerance, and it used for things where availability is very important, like in media platforms. So, okay, count of likes you will have kind of less than it should be, but still it works quite fast. So now switch our gears towards database types. First is key value databases, and they are characterized by a simple data model where data is stored like a pairs of keys and associated values, and values of any type. Such databases provide highly efficient methods for reads and writes because of simplicity. They don't support some complex queries because they operate only on the keys levels. So, but these databases are usually used with data persisted completely in memory, and it allows them to do a sub-milliseconds response speed. Where they good at? So they are performant, as I said, they are horizontally scalable and durable. So it's usually AP option in CAP. But they can't manage integrity in data because it's too simple, and yeah, the same about queries. The second type is document-oriented databases. They store data in semi-structured documents, typically using formats like JSON or BSON. And these documents can contain complex nested data structures such as arrays, subdocuments, and it's quite good. In terms of querying, document-oriented databases support some sophisticated query operations such filtering, aggregation, full text search, and it is even on this nested documents level. Yeah, let's talk about later. Also, yeah, about querying, they support join variations, but not in the same way as SQL does. Advantages: so flexible data model, horizontally scalable as well, performant in simple queries, I would say, and do support complex queries. Disadvantages: they sometimes provide some transaction support, but they are limited anyway, and they're not so efficient for simple by key lookups from the one side, and from the other side, for highly structured data, they also don't very performant. So like go deep into nested array here. Next, I guess familiar to each other, to everyone here, is relational database management systems, or RDBMS, or SQL. These databases store data in structured tables with rows and columns, where single row it's some record, and each column represents some attributes of it. These tables may be connected with so-called foreign keys relations, which allows to make powerful constraints and handle data integrity right on the database level. So they use a structured query language SQL. It's a powerful and standardized language. So offers a lot of complex query capabilities, and it includes joins, so it's good. From pros, they are ICID compliant always, and they support transactions, of course. They allow to manage structure and integrity of data, and they provide flexible queries. But they quite hard to scale horizontally, and yeah, it's really hard. It's possible, but it's hard. They're slow for concurrent access, And another side of managing structure, they are rigid for domain logic updates because of schema. The next thing here is a graph database. They store data in graph, like depicted here, with some nodes and edges. Nodes represents some entities, edges represents relations, kind of relations between them. So graph database tuned to keep up these relationships, and they utilize usually for querying languages like Cypher and Gremlin. Today probably will have a presentation about this. So yeah, this language is designed for querying data in graphs, and the kind of above of SQL abilities, they provide things like pattern matching, shortest path calculation, like hello Dijkstra, and some various other various graph-specific operations. Databases, graph databases, fast and convenient for relations, it's obvious. They provide flexible schema, and they may manage data integrity for you. From downside, they're not efficient for queries without relations. They may be slower than SQL, hard to learn because of new language, and as well hard to scale horizontally. Next type is wide column databases, also known as column family databases. They store data in sparse columns. Each row here consists of a key, partition key, and a set of column families, where each column family represents one attribute, and inside consists from few other columns. So email here, it's not a column one, it's column family. Time series databases are just variations of these wide column databases, and they are tuned to work with timestamp data, where timestamp used as partition key. Query capabilities in these databases vary and engine specific, and they do provide filtering, aggregation, but don't provide joins, and not so expressive like SQL, for example. So where they good at? They good at write and OLTP queries. They're horizontally scalable, highly available, do have scalable schema, and sometimes even may compress data inside. It's good for time series databases. From downside, they have limited query capabilities, hard to learn, and complex in maintenance to kind of achieve this level of availability usually. Other thing is search engines like Elasticsearch, Splunk, Solr. So they are built on top of a specific data structure called an inverted index. This data structure maps multiple terms parsed from text field of different documents they appear in into table where kind of we have term parsed and document where it appears. And this structure enables these database engines to do fast and efficient queries to find these terms. Such search engines may perform the same queries as document-oriented databases, but additionally do offer some things above these inverted indexes, like search by regular expression, human language specific functions. So we know these things, they differ between languages, rankings, search with typos, and so on. So they are performant for these searches, of course, provide flexible queries and horizontally scalable. But kind of the same, mostly drawbacks like for document-ready databases, it's a limited transaction support, doesn't have joins, and additionally, they need a more powerful machines to work on. And the last database type, which I want to remind you about, it's vector database engines. They store data as vectors or as like arrays of numbers, where each index, each number represents some feature of the data. Such representation is useful for applications involving machine learning, recommendation system, or as other AI purposes. From the querying perspective, this database provides actions like k-nearest neighbor search, similarity search by some predefined functions, and other multidimensional range queries, and everything in this list with without doing false scan of the data and with a great precision. So who worked with it, I guess they know how to achieve this. But yeah, these queries are very specific to database engine, so not so standardized right now. Yeah, so this database is efficient for vectors data, horizontally scalable, but they don't provide transaction support. They also require some powerful machines, and they are complex to manage. And now let's switch to assessment table, comparison table. So where I want to provide some information about database existing, so open and free to use databases from different types, and explain some kind of way how to choose persistence for your database. First thing you need to ask is, do we need to be ACID compliant? And yeah, it may limit your choices a lot. Next one is queryable types. It's very important things because if your database doesn't support some search capabilities, then you either would spend a lot of time to invent something complex right in your application, or will execute just full scan in the collection of entities for some maybe important part of your application. And it would be very inefficient, and it would make obstacles for your project to scale. Some more clients, but it's slower. Joins, yeah. Why it is important? Because performance of query depends on data locality. You just can't make an efficient query when for each item in the collection placed on one server, you need to make a network round trip to another server, and so on. Yeah, adepts of NoSQL databases assure us that you don't need joins. Just embed like comments array into articles entity, and it would work even faster than RDBMSs. Well, that's right, because data locality in such case is the same collection, and it's faster than HDBMSs when you will have two tables with relations between them. But it adds some penalties, and this penalty is denormalization of your data, which means that when you would need at least some new page where you have to provide all comments for this specific user, then in this case you won't be implemented with existing data structure, and you either will duplicate your data in a new collection specifically for this query, and therefore get duplicates of data and earn some integrity problems with it, or you will struggle with full scans of these articles, and again, it would be much more slower. yeah, please do think through your application requirements up front, because persistence is a long-term investment and it's very hard to avoid coupling your application logic with choosing database type. So the next is CAP's theorem, which may be important for distributed databases. So if you know that you would have something distributed, then of course it is important column. Next would be some write performance and read performance, but it was from ChatGPT, so don't believe in these numbers a lot. And maybe other attributes which you might use to choose persistence for your database. And now let's go to examples. Here I provided the first example, which for some small, general, low-load application. And let me explain what it is. So we expecting to have less than 100 active users. They will do manual updates. It would have some UI with personalized queries. So it means authentication, maybe search by text and stuff like this. So we don't sure yet in general, but idea and around this. From non-functional requirements, we want it would be as cheap as possible. So it's free hosting or maybe some small. We agree with any performance right now, and together with this, we want the ability to grow at least 10 times. So kind of if it starts to earn money, then wow, we want it to be kind of support all these new clients. So ability to grow very important for such kind of applications. Let's try to translate this into requirements to database layer. First one, what we see is we don't need a big write performance. Yeah, 100 active users, it's not so much. And yeah, manual updates, again, not so much. From UI part, we don't need a big read performance. Because again, when less than 100 active users won't generate a big load on our application. We do need support relations and multiple entities. Yeah, authentication tells us about it, and in general. So usually our application would have more than one entity in these relations. We do need complex queries. Yeah, at least search by text, it's not so easy. And because this text may be placed in different attributes of our entities. And these things are clear, but ability to grow. Yeah, we want to scale, so it should be a scalable solution. So let's try to convert all of this into decision. From all these thoughts, we may conclude that the best option here are DBMS, in spite of scalability, because it would simplify applications code a lot and would keep up with this load, which we are expecting at least a couple of years, at least until we would have enough money and domain knowledge to migrate our applications to some new persistence. The second option is a document-oriented database, but the number of relations may be a problem here, and better to ensure that it will be small enough. So I put here less than 10, it's kind of sum of entities and relations between them. If we take other side of spectrum, like we do know that we need a lot of relations. So in this case, we might take graph database. And in this case, it would be justified in spite of complexity and some power, resources consumption, still could take load from complexity load from our code to the base level. And my personal advice for such kind of project, it's database as a backend solutions. Things like Pocketbase, Upabase, Firebase may allow you to launch your application completely without backend or only with small patches into existing code base, so into these solutions as well, so that you may patch them. These solutions would cover the whole authentication flow, users' data, blob storage, and other boilerplate aspects within a few clicks in the built-in UI. So look at them, it's powerful things. And now we are ready to look at kind of second example. And here I want you to challenge a little. Please look at this QR code below. It's a link to our voting page where you may provide your guesses. Which persistence looks better here? And after investigation of this slide, we will switch to it and look at your predictions. Okay, so please use it. And about this example. So imagine we have a factory with multiple rooms and multiple sensors inside each. The main purpose of these sensors is to be used as fuses for some dangerous conditions in the room, like too high temperature or low voltage, or some proximity sensors, alerts, and oh, it's too close, kind of maybe cut it, I don't know. So they kind of use it in this way to be switches or fuses, but our customers, to decrease the amount of incidents, make this alerting more sophisticated. So our customer wants us to connect all these sensors together into one big application with new features. So let's look what we want. So input data is near 1,000 sensors and 10 types of them for now at least. Each sensor generates like 1 kilobytes of data each 200 milliseconds in mean. Maybe some works more frequent and send less data. So in general. From the feature side, yeah, so customer want to have a dashboard where all sensors data would be drawn on some graph simultaneously. So from all sensors. It would have 100 active users, and it's usually relevant for these dashboards to draw data only for today. For yesterday, it doesn't matter. Application should provide analytics API, and here you need to provide at least 1 year of history from all these sensors. And we are expecting it to be called not frequent. And the alerting part, yeah, should be go to our applications. We are going to do check on sensors data like out of bounds, is low or more. Latency less than 200 milliseconds, but of course as fast as possible, because it may cost life someone. And also we want to, so yeah, if incident happens, then something switches off or switches on. Some people are getting called and texted. A lot of happens. So we want to attach all related actions to this sensor data, exactly this time, to this event. So I guess those who wanted avoided here. So let's go to waiting up, and okay, I see a lot of guys pretty confident that it would be time series or white column databases. But there are other options. Okay, fair enough. Let's see. oops. Yeah, let's make it a little bit wider. Let's do a quick math. We have thousands of sensors, kilobyte, 200 milliseconds, and together they generate 5 megabytes per second. It's quite intensive, but still usual magnetic drive may handle it. Next, as you remember, analytics API need to keep all this data 1 year at least. And from this perspective, we are getting 150 terabytes of data to store. So it's a lot. Rack of disk for sure. And we need to keep up with it somehow. Maybe compact data on the disk. Okay. Maybe sort out some duplicates because sensors probably would send the same data very often. So who knows, but it's a big thing, 150 terabytes. About alerting requirements. So kind of handle this volume of data and react in 200 milliseconds so kind of connected, it's very tough. So easy solution here, just handle alerts separately from persisting it in the database itself. So just kind of each event go into 2 parallel branches, one to persist and one to check for some conditions, for alerting conditions here. Let's think about reads. So as you remember, we have 100 active users. They want to see all sensors data on graph simultaneously. So it's and yeah, it should be kind of real time. So again, very fast. Yeah, and one more thing here, it should not affect the write part. So if kind of everyone from 100 operators will hit refresh, then our sensors data shouldn't stop to be persisted. So we clearly see that the database should not lock on read or writes. It should be on parallel. So eventual consistency is kind of okay with these requirements for speed. One more thing, a good latency is needed only for the last day. So dashboard would be drawn for the last day data. It's for analytical APIs, and for analytical APIs we don't have some performance requirements. So let it be our trade-off. But for last day, it should be as fast as possible. And here, a good idea to separate persistent on cold storage and hot storage. So hot, it is what we want to draw on dashboard, so last day. Older data in some other thing, magnetic drive, it's cheaper. Yeah, about variety of data. We have 10 sensor types. Maybe it's 2 collections, but if look deeper here, we may find out that attributes would be the same. At least timestamp, column would be the same. Location also would be the same. Type, maybe something else. And to don't make our application more complex with collection per type, better to write into one collection, but be sure that it's schemaless persistent. So, for example, if we will add new sensor type, it would work here without any big changes, just kind of new way to query data. And the last condition, which is quite tough as well, it's about how to attach related actions from incidents. Sorry. So looks like this incident data may be quite complex, so at least few entities, relations between them, but performance requirements here are kind of very small. So I guess incidents happens quite rare. Otherwise, factory is bankrupt already, maybe. So good solution here would be use separate database for alerts data. Because access patterns and performance requirements are completely different here. Yeah, RDBMS would be a key. Yeah, about how to connect them. So we may persist only sensor event ID in the database. And if somebody will need kind of see raw data, it would be linked. But most probably here would be queries for kind of total picture and for alerts data, not sensors data. So conclusions. Yeah, I guess everyone here is a good engineer because from my side, time series database is the best option for such sensors data. Maybe any other white column database also, because write performance is good, keep up with a big volume, so very suitable thing for this application. Document-oriented databases are not designed for such volumes, so making them run these volumes will require some solid knowledge in the chosen database engine. So, for example, if we are going to use MongoDB, then it should we have to have an expert in it. Yeah, about write performance also, it's a question because again, need to build solution with this whole persistences very careful. One more alternative here, it's a keywell database, and in theory it looks faster than time series database. But if think about our usage patterns for dashboards, then we may end up with even slower performance than time series database. Because if you remember, keywell database query separates on the keys only level. So, okay, we will cut out kind of only this last hour, for example, data. Okay, but next we need to separate this data on different sensor types, like show temperature sensor on this graph, voltage sensor here, proximity here, and so on. Also, dashboard may require something more complex, like I don't know, only in this room, or only of these specific types of this manufacturer of sensor. I don't know. So actually, it would require to do all this aggregation and filtering on the dashboard application, so on UI part, and it would be quite hard to keep up with. So it's questionable. Next, go to the last example. So here you may find different QR code to the second voting page. So now you know more methods and are aware about more assessment attributes. So I suppose your answers would be more confident. You would have more answers. So please scan. And yeah, here we would have 2 slides for requirements because it's not easy application. So what it is? For example, we are going to some vacation and want to find some good tours here for us for the home location. So we are typing some location, say city, country, I don't know, something quite a big from geographical perspective. Duration of stay, budget, interests, and hit search. And the application should provide us with list of plans with these tours. Like for Monday, we are going here, Tuesday here, and so on. and list. So yeah, some variations, different options. You just scroll to choose what looks better for you. Also, these plans should be editable. Application itself should provide notifications to users, reminders like, hey, your tour is in 1 hour, please go catch bus. Notifications to tour providers, so to make them aware how many people are going to choose their tours. We are expecting 500 active users per location. 10,000 active plans. Active, it means not finished yet. 30,000 tours per location, and these tours will be generated by 5,000 tour providers. So it's kind of max what we would have. UI. So what our application should provide from UI perspective. By some metrics, we want to search take less than 7 seconds, because if it is longer, it's too long. Search bar includes a lot of conditions, so it's not only location, budget, duration, interest, might be kind of a whole spectrum of different wishes from our side. And probably we would add AI later on, but right now, no. So tours should have pictures, providers, reviews, likes, all this stuff. Tour providers the same, reviews, likes, and stuffs. Notification reminders, let's do them each hour. Notifications about bookings, immediate, fair enough, yeah. And also we know that tour updates are rare, because it's quite hard to kind of create new tour. So I guess everyone voted. Let's see, voted. Okay, so leader here is a relational database. But there are ideas about document-oriented, vector, graph. Yeah, time series is not chosen. Okay, fair. So let's proceed. Let's try to convert this direct free explanation to persistent requirements. And first thing, looks like we may separate our persistence by location. Why not? It would allow us, for example, do some geo distribution for our persistence, and in this case, kind of improve SEO metrics, SEO optimizations. But it kind of not so easy, because we have to be sure that relationships between locations don't exist, or at least they are not required for some common queries for our application. So you need to be careful when designing schema or designing connections between your entities. We do need the complex queries and the multiple reactions, because authentication, different entities, and so on. Probably don't need in geospatial indices, and maybe not full text search, but we don't know yet. So yeah, all these points on HDBMSs or graph databases because of relations. Probably about this geospatial and full text, they may be added as plugins. For example, for Postgres, MySQL, there are some plugins. Neo4j, it's a graph database, they have geospatial built-in. So yeah, we may keep up with it. About performance, if you remember, 30,000 tours in one location. Let's estimate they take 1 megabyte on the disk. It's long description, and a lot of links to pictures. links to maybe reviews here, something. So a lot of links, mostly. Also 10,000 active plans, and each plan would be 100 kilobyte because they don't have to persist description. At least it's only links to some tools, and together it's 31 gigabyte per location, and it is not so big. Sometimes it even may be put into memory. But okay, for our side, from our perspective, for DBMSs and graph databases are good enough to keep up with this. Write load. So we know it will be small by providers, and main load here would be generated by 500 users, active users, if you remember. But most of them would do searching, not writing. So we may conclude that write performance is small. Manual inputs from 500 users, it's less than 1 megabyte per minute because of speed of typing, mostly. Read load. And here is kind of quite tough. 500 queries, and all of them should be somehow handled in 7 seconds. And yeah, as we know, our DBMS is not so good for concurrent access, so we need to speed up this part. And a good idea to add indices for all searchable fields. Yes, it would impact our write performance, but as we know, we don't need some big write load, so it is a trade-off. So okay, write is slow, but read is fast. Also, again, hint to designing, it's need to avoid for read blocks, except I'm booking. So yeah, if we are providing booking feature for our customers, and we have a limited number of seats in bus, for example, then yeah, booking should be reliable here. But it would be separated, maybe separated, separate part, separate table, separate log. We are using. And the last thing is about notifications. So let me remind you, notification reminders each hour and notifications about booking. So from notifications about booking, it's clear. So kind of we may just send it in parallel with persistent, with storing this information in our database. So it's okay and it's handled per user. About notification reminders, it should be some cron job each hour, and it will do the full scan. But it's only 1 query per hour, and it will be quite simple, sort by start time. So it's not a big addition to our kind of 500 simultaneous search queries. So from this perspective, we may see that, yeah, RDBMSs is the best choice here. We don't need big write performance and doing it in schema and relations, so it's good to go. Graph databases also may work here, but it's justified only when search would be mostly based on relationships from some specific users or other entities. Like instead of sorting or requesting, so when you provide plans, if you want to sort them not by the total number of likes, total number of reviews or something like this, we want to sort them like was chosen by users from the same country of our, or by number of mentions in the media, or by this blogger likes it, so yeah, it should be the first, so something like this. In this case, yeah, graph databases might improve performance because it's main load here, and from the RDBMSs, it's not so easy to keep up all these relations, maybe between the same entities by different types of relations. Document-oriented databases also alternatives here, and it's for the another end of the spectrum. When we have carefully evaluated the model of relationships and sure that cross-collection queries won't be required for our pages. So we know how many relations we would have and not a lot of them. So here we may build something on the application side to, or maybe design our, put comments in articles and so on. But we sure about it. If we don't sure that, document-oriented databases may be risky. So it's all for what I wanted to present to you. Related resources may be found, I guess, later somehow. Thank you for your attention, and I'm ready to answer the question.
Thank you very much, Alex, for your work. It was really informative, and I'm sure that we have lots of questions. So now let's see what questions your presentation raised, and let's try to answer them.
Yeah, what a lively discussion we have in the comments regarding the satisfaction of all sides of the CAP theorem. And the question that raised this discussion was, many new database as a service providers claim that they can cover all aspects of the CAP theorem without any trade-offs. Is this claim false, or are they using some clever technique?
Good question. In short, they are kind of lying a little, because, so let me switch to this slide to be more, to provide more background here. Theorem is it's a global thing which not easy to somehow hack. So if somebody claims on their side that they may provide fully compatible CAP properties, then there are two options. First one, you would suffer in performance a lot, because it may be possible to provide, for example, all three aspects in the same place, but each query would be very slow. Just it should survive any network issue. It should survive writing on all nodes, maybe on some geo-distributed database, because if you remember, it's distributed database. So it's one side. The other side, it as options from the manufacturer that and the option from this theorem would be provided based on your needs. So if they may see that you are especially interested in consistency and availability, but agree that some network issues may be a problem, then they would just provide consistency, availability configuration for database, and you would be kind of happy. So it happens in this way usually.
I see. So it's tricky.
Yes.
Okay. The second question is, what is fuzzy search, and how does it differ from full text search? What are some of the most reliable sources of data persistence that can handle both fuzzy and full text search, and what are their advantages and disadvantages?
Quite broad question. Full text search, it is usually something limited with contains statement. Fuzzy search, it is more closer to regular expression when you replace some part of search text with some asterisk or question marks or some pattern, some placeholder, which would mean anything inside. And yeah, so if we are talking about search with typos, then fuzzy search, it is a thing which need to see it. And yeah, search engines kind of may provide it. The only database type which may do it fast, at least fast. Some databases even cannot do them. So search by regular expression, for example, is not possible in SQL. If you need full text search, so again, it's a question what you mean under this. If it is about contents, that yeah, it's just kind of if some string starts from this, ends with this, or it in the middle. And it may affect the index type which you may choose to perform fast queries with this. Because SQL, we have like operator, it works like contains. It's not a regular expression. But to execute it performant, SQL should have, your database should have index for this thing. I mean, for performance use case. If you don't need in performance, then you may use it as is, and it will just do kind of full scan, which is may be a problem. So it depends on the application. And could you remind me what was the second part of the question?
What are the advantages and disadvantages
between these two options?
Yeah, between these options, yeah.
Flexibility. So if you want to forgive mistakes for your users when they search something, then fuzzy search or this search by regular expressions may be a kind of suitable thing. If you don't need in such flexibility, then don't over-engineer it. Yes, it's a way to choose.
Okay, and maybe the last one, short question. You told that there are some databases which have a multi-model type. What does it mean?
Yeah, there are a lot of mostly kind of paid solutions right now, which may provide. So if you remember differences between engine types, which I listed, how they store data inside, and it affects how fast some specific queries. So with sophisticated tools, with a lot of maintenance hurdles, we may implement databases which may store data kind of in different ways. And based on this, speed up some queries and kind of with trade-offs to another type of queries. And it called multimodal database. Usually, I don't know, FaunaDB, as I remember, made this thing kind of in true way. There are some cloud providers databases which also claims that they are multimodal. It just means that they kind of try to combine pros from different database types and somehow make cons from them not intersect with each other. So in general, it looks like this.
Yeah, thank you, Alexander. So that's it. Could you please choose the question that is most reliable and interesting for you?
Oh, so I guess I like the question about full text search and fuzzy search because it makes me think, and it may be a good addition to your assessment for the application type, for the database type. So maybe it would be a corner point where to choose this database or this database.
Okay, thank you. Dear guests, thank you for discussion in the chat, and please feel free to ask questions. Alexander and he will answer that one that we haven't mentioned now. And now, yeah.
Now, yes, let's welcome our next speaker, Jelena. She's an experienced software developer and ex-Microsoft Most Valuable Professional. Her talk today is about being artificial intelligence chat, a powerful tool for developers and learners. Jelena will show us how this AI tool can boost our productivity and help us with daily tasks by generating code for us. So, and now I give the floor to Jelena. Jelena, you may start, please.
Thank you for nice.
Hi, Jelena.
Hi. I will share my screen now. Okay. Is everything okay?
Yeah.
Okay. Hello and welcome to the session about being AI chat, powerful tool for developers and learners. In this session, we will talk about AI tools, how strong impact they made in short period. Next, we will mention some basic stuff related to Bing, when it was published, how we can start using it, and the ways of using it. We will mention types of conversation and talk a little about prompt. After the introduction, I'll pass through the steps for building a simple application with Bing AI, and then we will go together through the steps I created after I realized how I should prompt. So a small introduction about myself. My name is Jelena Miodragovic, and I'm from Belgrade, Serbia. But I'm currently live and work in Banja Luka, Bosnia. I'm Master of Engineering and Software Developer at Sivas company with focus on front-end technologies. In the late time, I mostly work in React, but in my past, I had experience with a lot of different technologies like mobile apps, Azure, IoT smart devices, and Microsoft Dynamics, and so on and so on. I was a speaker at conferences and user groups, mostly in my region, Serbia, Croatia, and Bosnia. Also, I had a reward you heard about. It was a Microsoft Most Valuable Professional for 3 years. I'm also very active in IT community, as I am co-leading one user group that is called Belabit here in Banja Luka, and I'm on one of co-organizers of one conference in it, also here in Banja Luka. These are just some of the highlights, and sometimes it's hard for me to count all the things I done and I currently do. But for some reason, for that reason, it's easier to say that I am simply a tech girl. As you know, you all heard about AI tools that suddenly became part of our lives. So, especially if you're a developer, you have some doubts about AI taking over our jobs. But is that really possible? Or it will increase our productivity and replace only developers who are not using it? In this moment, you don't have to worry. But if you don't accept new things, maybe you have to be worried. So I'm going to ask you 2 questions. The first one is, do you think that AI tools will replace developers? So use this QR code to answer yes or no, and we will see these results in a few seconds. I don't know how much we should wait. Can someone give me a sign when we should see the answers? Okay.
Looks like the QR code is wrong.
Yeah.
For the second question that you wanted to ask.
Oh, okay. Never mind. we will replace it. So the second question is, if you use an AI tool to help with programming every day, write down which one it is. Okay, maybe maybe I should go this. So this one is not filled, and I will go back to this one after I ask the first question I should ask. Yeah. Okay, I will continue. I know you all heard about Googling. I'm talking about I wanted to talk about some habits I have with Googling, and you know, I had Googling all my life, and I had the habit to Google it. But when I start using a GPT 3.5, since the day it was released, first thing I noticed that I try to solve my problems with coding is that I start Google it by default. And then I switch to GPT and solve problem in seconds. Then happened a couple of times until I realized that I'm getting back to Googling because of my habit. I had a transition for some time, and I was like constantly reminding myself to stop Googling. And, you know, I have an AI now. Why should I use Google? I have all I need with this AI tool. And then I got switched 100%. Not only that I start using it in development, but in all areas of my life. Also, I'm working as a lecturer at one IT academy. And for that purpose, I had to make tons of examples for my students and make it easier for them to understand JavaScript. And as you know, that JavaScript is not easy to understand, even if you have a huge experience. I mean, I don't understand JavaScript, but I like it. Yeah. So there are many AI tools that that you can use, but most of them are based on OpenAI platform. Okay, so I guess this one is for the first question I ask, and that is the question about replacing AI replacing developers. So you can use it to answer your question, and we will see the answers for those two questions. Okay. Maybe I should now go back to this slide with No. Well, somebody said yes. Yeah, I would like to know why the response was yes. So please type in the chat. And we will see now the second response. Is it a problem with QR code or
Could you please click the link? Maybe it will work. Not embedded here.
Not embedded. Okay, I think this one. Yeah, great. So this add-on is not working good. Bard, somebody is using Bard. Nice. GitHub Copilot. Okay, I like. Oh, somebody is using Bing Chat. Oh, in Skype. Yeah, I used it. Yeah, that is one of the options I wanted to mention. Okay. So I guess we can go now to introduction to Bing. Yeah, maybe you heard that at the beginning of the year, we all witnessed this race of the big companies to place their AI tools in the better light. And they look a bit funny to me because they look like some kids arguing which toy is the better. Yeah, we saw some fails like this meme we have here, and we have some wins. As for the Microsoft, they started to integrate AI tools in AI in all possible tools. So we have a Copilot for GitHub, and we have a Microsoft 365 Copilot and Azure OpenAI service. And at the end, we have a Bing AI, which is today's topic. Bing has launched a few years ago intelligent search feature, which provides the exact piece of code a developer is looking for. The code snippet that appears on a search result page means that users don't have to skim through long threads. This Bing's feature is designed to help save developers' time. In February 2023, Bing is AI-powered with GPT chat. There is a difference between Bing Chat and ChatGPT on how Microsoft has customized it. Bing Chat is tuned for search, and it lists sources for everything related to that search. Also, Bing is using OpenAI's latest LLM, large language models, GPT-4, while ChatGPT has GPT-4 locked behind the paid plus subscription. I think it's 20 per month. So now we'll see how to start using a Bing, and I will share my Bing. So you can see if you are already using a Bing, or for some that are not using it, below this search bar, there is you can find the chat, and also you can see here that you can use this sidebar for chatting. All you have to do is to click on this Bing icon, but we are not going to use it in this demo. So there are two ways to transition between search and chat. First one is to click on this, to click on chat, and the second one is to scroll with mouse. In order to start using it, you need to have a Microsoft account and to request access to this early preview of Bing AI Chat. Before I start using it, I was on a wait list, and it was short period. And after that, I got mail that my access is approved and I can start using it. Also, besides Bing Chat in Skype, you can use it here in Windows 11. Here is here is that chat icon. So for this warm-up, I will start typing just to see how it is responding. So I will type find method in Java script. You saw that that auto completes it. I mean, it has when you start typing, it predicts what the next word will be. So we will see what it will get on this search. We have here from W3 schools site, and we have some code snippet here as an example. And after that, we can use chat to see what the response will be. Okay, so we have some small, short description of defined method, and below this description we have some extra sources to go, and these are some bubbles with prompts we can use next. After that, I will, for example, if I wanted to use Bootstrap, I wanted to have a list with some steps to install Bootstrap. So I will write steps to install Bootstrap. See the response. So you can see that this is a very nice list of steps to install a Bootstrap. For some beginners, it is very good to use it like these first baby steps. Okay. One thing I skipped is if you can see there are three conversational styles here: creative, balanced, and precise. First one, this is a creative, longer, more descriptive, and creative answers. Second one is balanced. It's somewhere between first and third. And at the end, we have more precise, shorter, straightforward, search-focused answers. So for this investigation, I wanted to know what is the difference between them, and what should I use to get some help in coding. So I asked Bing what is the best conversational style for help in coding, and I got the answer that more precise conversational is the best for me. So I wanted to test it. I tested. I put prompt, for example, something about coding. Let's say, give me an example of creating a JSON object, and I waited to see how my response will be when it is creative, and how it will be if it is precise. And I noticed that Bing's advice that I should use more precise is much better, because it was more strict answers. So the one thing which is maybe the core thing about this presentation is about prompt. As I have been using a GPT lot lately, I noticed that there are a lot of articles related to its proper usage. Things are developing really fast in AI world, and I really didn't have the time to process that information. That prompt is very important, as I always get what I want from GPT. But maybe if I use that articles to inform myself, I would get it faster. You will see through this demo today that I'm not an expert in prompting. But creating this session, I got a new feature, me as a better prompter. So I'm pretty sure that this is a skill we all need to unlock to get the maximum capacity of GPT. So at the beginning, you will see a lot of average prompts. And at the end, I made 4 strict prompts made from my experience based on first attempt to create a simple to-do application. So we will now go back to the slides, and I will show you my first steps for creating a simple to-do application. Okay. So this was my plan to make a to-do application. First one, because I am simulating some junior that doesn't know about anything about React. I need to know something how I can start with create React app from scratch, and then I needed to install and configure Tailwind. Just to have some, I got used to it, Tailwind. I like Tailwind to use in my components. And after that, I wanted to make components home, to do, reminder, and navigation bar. At the end, I wanted to create a navigation with React Router in the app.js to render it. So these are steps for creating a to-do components. And I didn't put all the prompts in this presentation as some were repetitive. This was really tough because I reached the max 20 from 20 prompts. And here are just 9 prompts I used. Okay, in first prompt, I asked Bing to write steps to create to-do application with React. I got nice detailed list, and I will show you now the screenshot of that response. Maybe you remember when I typed about Bootstrap. So it is similar, very detailed list, and I really like this list with steps. So I wanted to, based on that list that being created, to make all the other steps. So the second thing was to write instruction how to set up Tailwind library. Yeah, it gave me a detailed explanation with some links of videos at the end. But then I asked Bing to use steps, as I mentioned, that it created in first response, and to create to-do component. It wrote component, but forgot to export it at the bottom of the component, and it didn't render it in desired place. So I asked to render component in app.js, and I wrote another prompt. If here are some React developers, they will know what I am talking about. Because this is a React-related application. Okay, now I got to-do component, but it didn't had remove from list option. So if we put some to-do in a list, we have to remove it, yeah? So I asked to add it, and I noticed that input field was missing. I forgot to mention styling with tailwind in my third step, so I asked him to rewrote, and being rewrote component with some basic styling, but elements were all over the screen and not centered or aligned. We will see what will today happen. I don't know why I expected more beautified code, but maybe it doesn't have an eye for a nice, I don't know. Okay, so at the end, I wanted my component to save items in local storage. So when user refresh the app, it doesn't lose information. So here we have a big problem. It tried to solve it and rewrote the component a couple of times. Then being proposed to troubleshoot this issue together, and then debug started. Together we tried to check my browser if it's blocking local storage. Then it asked to share my entire to-do component with it. Like I generated, not Bing. I didn't understand that, but okay. Bing rewards a component with some console logs in code, but we didn't find any problem. So I was examining that component that Bing rewards, and I saw the problem in the code. The problem was with use effects hook, and there was no render to trigger it, so it doesn't set items from the local storage. Well, that was then everything was okay because I wrote to Bing my idea about the problem, and it solved the problem. Yeah, that was really great. You can see, you can't see here all prompts listed. Believe me, we had an argue about this to-do app, and it was really tough. And I had the luck because at the last prompt, I got what I wanted. It was literally 20 from 20. If Bing didn't give me a good response at the end, I had to do it all over again from the start. And that is not good. That is not what I wanted. So the part 2 was to create a reminder and calendar model component. On first prompt, Bing wrote some logic for adding an event to Google Calendar, but it wasn't good enough for me. After styling with Tailwind, I gave Bing the list of calendars, Apple, Google, and Outlook, but the logic it wrote on handle adds to calendar function was incomplete, and in one moment Bing wrote switch statement with some comments in it, and for me to write it myself. In next prompt it deleted. Like I noticed that problem that like it keeps forgetting stuff that it created. As I created the prompts, like I'm talking to some old man, trying to be nice, as you can see, please write me something, please, 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 I use that word. For some reason, Bing keeps forgetting code or some parts of them. That was the moment I realized that I have to start using something like in previous code, in code above, and finally use the same code, as you can see, use the same code above on the 8th prompt. So I started with that, and my response were better. Okay, so this is a second part of this second second component. But then new problem begins. The code is huge and incomplete. I tried to copy paste that code that being created to send as a prompt and ask things about that code, but it couldn't fit in 2000 characters. Then one idea came to my mind. I can ask it to delete logic that is not implemented, that calendar part I told you about in switch statements, so the functional parts can fit. Okay, code now fits, which is great. Now I wanted to have two separate files for two components, as it gave me these two in one file. I didn't want that. I'm keep repeating myself as being is keep forgetting stuff. When being finally separated, the code was incomplete again. So it wrote reminder.js, but not calendar model.js. It was not complete. My idea was to ask only for a second component to rewrite. So I finally got what I wanted, and that was 70 from 20 prompts. I didn't reach the end. Okay, so third part was to create home and contact form components. When I asked to add pictures from online sources, as you can see here, I add background and pictures from online sources related to application that contains to do so. I try to add some details for it to figure it out what should that picture based on. But I got picture of whale, and the second one was Immanuel Kant, Immanuel Kant's gravestone. I don't know in which connections Kant is with my application, but okay. Well, okay, I thought it's not easy to be AI and to satisfy all human wishes. Okay, I had no problem here. I got two new separated components very easy. And this was 4 from 20 prompts. Part 4. Create a navigation bar component and app.js. I mean roots in to configure roots in app.js. When creating on first attempt, when creating a navigation bar, I got component with A tags, which I didn't like. I wanted to use a React router, but I didn't mention that in this step, so I prompt to rewrote with React router. In the next step, I got code that I didn't like. And after several prompts, I made this code look as I wanted. The last problem I got was switch component from React router that being used in app.js. That component was deprecated, and I was curious about that, why it uses switch. So I asked. And I will show you here is a screenshot of response from Bing, why it uses a switch. And this is really interesting answer. It is clear that this response that is using a mixed source of data. As you can see, as of my knowledge, which was last updated 2021, the last version is React Router version 6, but according to recent web search, the latest version of React Router is version 6.10. And this is very, very interesting. And after that, it gave me the right code. And all I have to do after that is to fix import paths and copy paste it in my Visual Studio Code. That was 10 from 20 prompts. Okay, and at the end, I ask Bing to write a README file just for fun. Okay, now I will demonstrate this first application that with all these steps I made it. And I will find my application. I will start it. Okay, so as you can see, this is very basic, basic application, but I guess it looks nice. So it's very interesting, but okay, this is some kind of maybe, I don't know, dolphin, or maybe it's a whale again. I don't know, really. It keeps randoming photos, and here we have some interesting picture. Okay, below that we have a contact form. The submit button is not working because I didn't put a logic on it. But we can see to do. If I add item 1, item 2, no, item 2. Yeah, okay, I will remove. Okay, maybe I should demonstrate first that local storage stuff. As you can see, it keeps items in local storage. So here it is, this local storage with name items. And if I remove it, it works okay. The only thing I noticed after I finished this application that it doesn't have a validation with empty. I can add empty items. Okay, and reminder. Remind me to go to the store, buy some stuff. Okay, I will put it in calendar, and this is a modal, and I mentioned 2 times that this logic is not implemented. So if I go to these 3 buttons, it won't work. But the click outside will close this model, and it works on X. And if I click on send email, it will open Outlook and fill subject, and you can see here I should buy some stuff. Yeah. So this is how this application, first application works. And now I will demonstrate a real demo. After this interesting experience, I think I really finally figured out how to make only 4 magic prompts to build the same app. So I prepared them in advance. Also, I mentioned that I prepared empty project with same component names, same structure as the first app. I didn't want to waste time for this presentation. So I will copy these 4 prompts, and we will see if we can get similar or the same application as we got here. So first, I will show you how these prompts look like. You can see that I made a huge prompt, and I put every single detail in this prompts. So now I will open my Bing chat and copy paste this prompts. Yeah, one important note, sometimes Bing refuses to answer. It happened to me a few times. It just won't work. I don't know what is the problem with it. And let's hope that it won't happen now. Also, it never makes the same response. So I really don't know what I will get. So here is the first component I will create. I mean, Bing will create. Sorry, Bing. And after it generates a response, I will put it in my application. Okay. We have to always finish we have to wait for it to finish respond, because there is no way you can copy this response. So I should, yeah, this is my empty project. As you can see, it has the same structure as the first application. Okay, I copy pasted this first. It looks okay to me. Then I don't think I will have a problem with local storage. Okay, the second one needs to make two separate files, reminder and calendar model. So here maybe we should expect some problems, but I don't know. We should expect for Bing to give me unfinished code, because that response is very, very big. For now, we don't have any problems. Yeah, okay, nice. But you can see at the end that Bing started to write something and it didn't finish. So this is I guess this is unfinished response. But for me, it is important for these two components to be finished. I will copy paste this in reminder. Okay. One thing I wanted to do, I remember that. Yeah, okay, now it's all okay. Okay, so this second one is calendar model. Yeah, okay, I copy pasted. Yeah, so the third prompt should make home and contact form components in React. Okay, I got the first one. First one is home, and the second one is contact form. Nice. It is finished. Yeah. Okay. Great. So I copy paste home here and copy paste contact form. Contact form here. After that, we all need to create navigation bar and to render all elements with React Router in app.js. I hope so that in app.js it won't be using a switch, because then we will have problems. Oh, yeah, it's using switch, okay, but I have a solution for that. I knew that it will happen. Okay, so I will copy paste navigation bar. And the second one, can you rewrite app.js to use routes instead switch? No, I didn't get a good example. So I will do it manually, because we don't have a time to fix this, and I will just copy paste. So these are my imports, because it would give me incorrect routes. I will use this one, and I will render like this one. This I will using router and routes. So I will try now to see if it will be okay. This application, I guess. Yeah, okay. So we can see here that this is a similar application. As the first one, we have a photo and contact form. To do is working. If I refresh, it keeps in local storage, and reminder, well, I will do it like this just to test it. Yeah, you can see there are colors now, and send email. Okay, these are functionalities we needed and wanted. So I will go back to my presentation, and At the end, I will have a short conclusion that Bing Chat can help a lot in development. It is great for beginners. It can explain all the things it wrote, so anyone with little or no experience in development can understand what is written, not just copy paste it. For advanced developers, it can save a lot of time trying to find a solution for problems, but I think that they still can build complex things with it, not because they are not able to do that, but because we have to be very precise and explain it well. So we should prompt practice. And second, because it is limited with input of all information we gave, and also with output we get. 20 prompts per conversation means that if we don't get information we need in first chat, we have to start all over again. It is also limited with 200 conversations per day. And also sometimes it makes code with errors. Good things is that it supports training. So we just continue to add information on previous prompts, as you can see. On the last app.js, but sometimes it fails to remember all things that that it answered before. This is only a beginning of new era, and we will all be witnesses of what it will become. I have started planning my app with 4 components, but end up with 6 of them. And being a junior developer, created all of them with the help of my mentorship. All through the structure of the application and design looks very basic. It is still functional. And yeah, for the last slide, I wanted to thank you, and you can find these demo materials on my GitHub. This is the first QR code, and this is a contact with my email and LinkedIn address. And if you scan a QR code, second QR code, you can go to my LinkedIn profile. So I hope you enjoy it. I hope you will learn something new, and I hope that Bing AI chat will help you in your future development.
Yeah, Jelena, thank you very much. We definitely learned a lot of new things, and we also have something to think about. So, and while I'm trying to upload all the information I've got, let's see what questions the audience has.
Yeah, Jelena, thank you for bringing up such a trending topic.
Yeah.
Yeah, so we have some questions, and I think Natalia wants to throttle our chat. So the first one is, Microsoft has an access to all GitHub repos. Can we trust that they don't access data from private repos that are hosted there, or the ones that don't have open source licenses?
Well, I really don't know how. I really don't answer. I don't know answer to that question, because we are all fearing for our privacy. And I read something about some articles about exposing data to chat, but I don't think it's a good idea to do that. Especially because this is a new thing. And I don't think that there are regulatives that are, interfere with this one. So I really don't know. Really don't know.
Yeah, thank you. The second question: have you tried Find AI? Konstantin says that it's a new dev special tool, and he's very excited using it.
Sorry.
Find AI.
How?
PHINDAI. No?
No.
So
No. No.
Yeah, let's continue.
I know that you all have questions for this session, but believe me that this is really a new thing, and I really don't. I don't think I have answers for all of your questions. I really also I'm trying to learn to get the most of this new technology, and I just need to focus on my. I wanted to focus on my prompts to get what I wanted. But really things are going really fast, and I really don't know all the answers, as all of you already don't know.
Let's continue our questions. How do you think, what is better from your, what's better, Bing AI, search, or ChatGPT?
Well, I noticed that ChatGPT have quicker responses. But it is a good idea to compare how to regenerate the same thing. What will I get? Maybe it's a good idea for a next session. Thank you. Yeah, so I really don't know. I'm using the both of them, and first I used ChatGPT, but after that I switched to Bing AI, and I think the only advantage of ChatGPT is that it is faster. But sometimes you know, that is overloaded with requests, so it stops functioning.
Thanks. So, as I understood, you are not aware about any Microsoft plans. Yes, so we have any questions about the Copilot.
Yes,
and embedding
I'm not insider.
Yeah. I think the last one, maybe you can comment that. When will it get plugins like ChatGPT that allows more useful cases like generating physical source files? Some automated tasks where you can use it like some kind of CI/CD tool.
What is by physical? Maybe I didn't understand. Can you repeat it, please?
Yeah, let me try again. The question is about how do you think, when will plugins like ChatGPT?
Yeah, there are a lot of plugins for ChatGPT. Like, you can use it in browsers, you can use it in Visual Studio Code. I don't know if you tried. Someone answered that GitHub Copilot. It is using a GitHub Copilot, and I really didn't have a time to test all of that tools. But if someone try to get something, maybe and not getting a good response, maybe you should practice prompt. You can see from this demo that I used like maybe 50 plus prompts to get what I wanted, and after that I realized how I should do that. So when you're prompting, you should use more details and make a better prompt to get what you wanted.
Yeah, it's always working with such tools.
Yeah.
Jelena, thank you so much for answering. And as always, I will ask you to name the most interesting question.
Yeah, the most interesting was that one about comparison. Which one is better? Because
Bing AI or ChatGPT, yeah?
Yeah, because I didn't really have an idea to compare to make the same application with two of them.
So I think this is the topic for your next
yeah, I will definitely do
presentation.
that.
Yeah, thank you so much.
Yeah, thank you.
Bye bye.
Bye.
Thank you very much. So, and now we came to the next speaker, and it's my pleasure to introduce our next speaker, Yuri. He is a senior software engineer at Microsoft GitHub, and today he will be discussing GitHub's high-performance culture and how it enables top talent to achieve amazing things together. So get ready for a fun and inspiring session.
Yeah, Yuri, please.
Okay, can you hear me or see my screen?
Yes.
Yeah.
With the slides, I hope.
Yeah.
Okay, cool. Thanks for inviting me. My name is Yuri, and I will be talking about high performance culture in GitHub. You can find my handle on GitHub. It's github.com/radiantspace with all the social profiles there. Yes. So a couple of words about myself. I live in Tel Aviv since 2019, and I live a long time already in Israel. I started my IT career as QA, actually, and then transitioned to developing mobile applications with C# Xamarin in different companies. And then at some point, I was hired by Akvelon, actually, to the project which is named Microsoft App Center. And then within this project, at some point, I transferred from Akvelon to Microsoft. And actually, I attribute this ability to transfer to the way how both cultures of Akvelon and Microsoft align well, and which allowed, I think, partially this transition to happen. And then already in Microsoft, I was working on projects like Hockey App, integrating it with App Center, and then eventually shutting it down. And then we were working my team on NPM registry with all kind of technologies I mentioned there. And then finally, I was transferred to work on GitHub itself, because if you remember, NPM was acquired by GitHub, and previously GitHub was acquired by Microsoft. So it's some sort of like, you know, this babushka that one organization sits inside of another. But that's why I was transferring back and forth inside that. And I have to mention that all what I mentioned today is my own opinions and my own interpretations of what happens in GitHub within my narrow scope of view as the software developer, because this huge organization and a lot of things happens. Let's start maybe talking about why to focus on culture at all. Maybe you came here to listen about some technical stories, and this talk is completely not technical. So like, why to listen to that at all? And I want to tell a story about, it's actually an ancient Buddhist story, sort of like medieval. That's why I had this inspiration of drawing those pictures with AI related to somehow medieval drawings. It goes like that, that if you take a stick and let's say some man throws a stick in front of a dog, what the dog will do, of course, we all know, like the dog will run towards the stick and will try to catch it and maybe bring it back, maybe continue playing with it. But we all know this behavior. What will happen actually if you throw a stick in front of a lion? Please don't try this at home. And I never personally did that, but from this story, it says that the lion will not run after the stick, but it will run towards the source who was thrown to the person who was thrown the stick somewhere, no matter where. And the explanation here basically goes like that. So reaction of a dog considered less noble than reaction of a lion, because lion addresses the cause of the action and not the result or like some symptom of an action. And that's why like it explains that reaction of a lion is more reasonable and noble. So the culture stands inside, or like as this, it is the source of behaviors or processes of the company, which outcome in actual developments and products we build. So it's super important actually to focus on culture, not less than we focus on HR or engineering tools or software development lifecycle. And I'm trying to go to my next slide. Okay. Okay, so we will talk today a little bit about mission, how this culture will help us to, or helps us in GitHub with our mission and what this mission is. And then I will briefly explain what is that we want to focus on to create this high performance culture. And like, what is this high performance culture? What are main skills we want to have in place to achieve this high performance culture? And those skills are more universal. So this probably will resonate to what you have in your company or in your team. And there we will be talking about focus and the triangle of tempo, judgment, and accountability. And then the second half of the presentation will be focusing more on how we can achieve this, those skills, how we can grow those skills. And that's more specific to your company or to your state you're currently in. So if you want to get to some point, you already start from some place. And for GitHub in 2020, and actually this talk was based on some internal talk of our former CEO, Nat Friedman, at this time. So the company was at some state, and we wanted to grow those some skills or like to strengthen them. And then that's how we decided we want to focus on something. So building this recipe for GitHub will be the part or second part of this talk. And maybe for you or like for your company, you may have some different insights. What do you want? How you want to go there? And yeah, and this one goes like this. So our mission in GitHub is to actually build the best developer product in the world, no less than that. And currently, I think everyone knows what GitHub is if you're a developer, and it 100 millions of developers that use it every month, which they build products that affect billions of people. So we stay in this middle or in the center of this huge product that affects lives of so many people on our planet. And for this reason, one of the things we want to know to do is to create super fans. Actually, we want to with our products, we want to wow our customers, which are developers like you mainly, and that's why everything we do in GitHub, we have this customer obsession idea that we want to first focus on experiences that will make you wow when you just use, like, was it possible to implement it like it? Is it like it's super fast, it's super intuitive, and it that just get things done and like allows me to be productive and creative at the same time. And we also understand that actually we in GitHub, we do the best work of our lives in a way that we don't compromise for mediocrity. It requires from us to have this growth mindset, the ability to accept mistakes or imperfections in a way that we acknowledge them, we learn from them, and we move forward. And actually, there are many different companies in the world we can work on. So working in GitHub is a choice. And for me, it's also a big responsibility because of all developers we affect outside there. Yeah, and those are some cats that try to build a rocket here in medieval times. So what do we want to build to get this high performance culture? First, we want, of course, to have this high performance in the company. And this talk will not focus on that. It's like where to find them, how to get their attention and motivation to start with this company. And the second, what I wrote right here is actually how we build these conditions for high density of those high performance within the company. And for that, we actually want to demand excellence from ourselves, mainly because no matter what your role is, like I'm individual contributor on a project, but I'm still like have my own area of impact, which goes beyond just the code I write. It goes through reviews, it goes through meetings, it goes out through different communication channels. And this way, if I express or demand this excellence from myself, it radiates towards other pieces or people in the organization that will somehow will be aware of that, and like it helps this excellence to grow. Also, we understand that setting high bar is not comfortable. Yesterday, I think I knew while we was listening to this podcast with my spouse that humans, like this organism we all use to communicate with this world or navigate this world, we maintain, we consume about 80% of resources, like food, whatever we calorie intake, we consume this 80% of resources just for maintaining status quo. So if we lie on a bed or on a sofa, that's the amount of resources we consume to just stay alive. And then just imagine how much resources we need to spend in order to produce and make excellent products. And also, yeah, we understand this setting this high bar is the prerequisite for success, because if we like excellence will not happen on itself. In order to get excellence, we need to demand it and create it and strive to it. So what do we want to focus on within high performance cultures? 4 things. One is the focus. Second, and like 3 others are tempo, judgment, accountability. I will dive in a moment into each one of them. So if we speak about focus, it's actually super important to do anything in our life, regardless of what we do, like if we parent to a kid, or if we work in our job, or if we talk to our parents, whatever we do, it's super important to keep focus on our goal, on our current task. And the way we achieve this in GitHub to make those great products is that we try to build less things at higher possible quality. So our core product, which is all issues, pull requests, repository, CI/CD, Copilot. It comes before more, which can be like all different kind of nice features. So we strive to build just this small set of features at highest possible quality. And then also to achieve this focus, or to maintain this focus, we need to ruthlessly prioritize what matters most to our customers. So for that, of course, we need to be aware of what our customers want, but also once we figure out what matters most to them, because we can rely on assumptions, so we may check our assumptions and validate them, or actually discard them if the assumptions were wrong. Once we have those assumptions validated about what matters most to customers, then we need to prioritize and bring most important things to focus on them. And then we start with tempo. It's another key ingredient, which may be like obvious. To maintain high performance culture, we need to maintain this tempo inside the team. But when we talk about tempo, we can try to think about a clock cycle of our computer, which is our team, that have its internal processes. And it may be different because like we may be a member of a team of 10 people, which releases every 2 weeks a new feature, or we may be a leader of an org that releases a new OKR every quarter. And that's our sort of like focus of our team. So whatever our team is, we need to know and to tune our clock cycle in a way that it is fast enough. Then also, of course, it's super important not to overclock this. So the point of having this clock cycle is to be able to maintain the performance for longer possible period. Why? Because if you overclock, team will burn down, and then you maybe achieve one beautiful feature, and then there is no one left to maintain it. And then what does it mean to maintain high tempo is how often do we check and how much time we spend in uncertainty. So imagine you build a new feature and then you need to talk to different teams to get some approval for your architecture review and to ask customers. So how much time will you wait for all this to happen before you can proceed and move on? That's how we maintain high tempos. We try to reduce this uncertainty time. For that, of course, then we don't want to ship already a huge thing once in a year, but we want to split our feature into smaller pieces, starting with MVP, very beautiful, polished, but which does just one or two things. And then we will constantly grow this functionality by a new piece. And that's how we also show feature first and then get some feedback from our customers. And that's how we also know if we are doing the right thing, and not like after 1 year we discover that was a bad decision we made 1 year ago. So after we ensure to like if we have this ability to move fast and we grew this long and fit legs to move with high tempo, we also want to have keen eyes which will guide our movements. And for that, we need to make sure we make right decisions. This is also not something that is matter of seniority or talent. So making right decision doesn't have to be like a team lead or a most senior person on the team who makes the decision, but it can be attributed to one with experience or expertise. So even a junior or intern on a team can make a good call because maybe it's his area of passion that he spends so much time researching this area of, I don't know, machine learning. And that's why if we want to use this or this machine learning tool in our feature, maybe it's good to ask him and give his feedback for this kind of idea. And then also the leadership of the organization, it needs to ensure that they empower people who have shown great judgments to make decisions. So once we have identified people who constantly or regularly make good judgments, we want to empower them to give them more abilities to give calls and not like prevent them from making those judgments. And third thing we need actually is accountability, because I mean, it's difficult to tell if we able to reach our destination if we don't know who's driving the car, if we don't know who like if it's like 10 people who tries to turn the wheel because they all have different ideas, then maybe it's difficult to tell, or maybe it's easier to tell that the car probably will not arrive somewhere. And also very important to for someone to own the outcome. And for that, we in organization, we don't evaluate activities, but we focus more on results. And that's how we measure if this decision was successful, if we get the proper result. So I was talking 20 minutes now about what we want to achieve, and now let's focus to something different, which is like how we want to achieve that. And now I will tell something that was working in our case in GitHub 2020 sort of state of organization, and how was and that's what we observed and what we decided to focus on to get to this state of a high performance culture. For us, this recipe, this success recipe was making demos and not memos. So the more organization grows, we tend to invent more abstractions to somehow estimate our success. So if we are a leader on big organization, we want to have some KPIs, maybe some abstract parameters which will tell us like such and such features give some such and such percentage of satisfaction for our customers. But that makes actually a barrier for the far we are in organization from actual development, or like what happens, then we actually start to base our decisions on abstractions and not on what actually happened. And for that, we want to with every feature we make, we of course we have metrics and business analytics coupled to this feature, and performance analysis and whatnot. But we also want to couple this with some demo of this functionality, the way how user will use it. And as a leader also on a team, for example, a person would dive in and try to understand how exactly this feature work. Is this experience of using this feature satisfactory, or it's horrible, and like I click and I don't get response for 10 seconds and I don't know if I even clicked the button, I don't remember it anymore. So demos and non-memos is one memo to remember probably. Second thing is to build in quick iterative loops, which I said with these small slices. So that's how we want to ship our very fine polished features, but in very small slices in order to get feedback fast. And also for accountability, it's super important, this topic of GRI, because if we have committees for everything, for making decisions, for deciding which technology to use, like if this button should be red or violet or green, and we need to get information from all kind of different people and to make them all agree upon this decision, then it probably will result at not so fast tempo, and also probably it will not be so much accountable, such decisions. And then with how we decide, we want to move to a model which is named here consult and decide. I will explain it in a moment. So just to summarize, I want to talk a little bit about how we achieve this high performance culture in GitHub based on our state. So to achieve this high performance culture. And I was talking about DRI role, which is super important. So we want to have one directly responsible individual, and we have that for any project or feature we have in GitHub. To own this feature and to own the outcome and to be able to make critical decisions for this development. And our leaders, they basically help DRIs to succeed. So they give them enough autonomy and enough tools to sort of be able to focus and make these good judgments for the project. And DRIs can be changed without reorg or promotion. As I said, like DRI, it's not a title, it's not a parallel to or synonym to team lead. It's just a person who for some time can drive a feature, and that's why you don't need to have a reorg. So you finished with one feature, and for next feature we find another DRI, or maybe this same person will continue to drive it. And it can be, as I said, anyone on the team, not depends on seniority, but it needs to have some qualities, and I will talk about those qualities later. Then to make decisions for the project or the feature, we want to focus on specific model of making those decisions, and that is called consult and decide, because you can make decisions in different manners. You can make decisions from top down. So like I decided like this based on my experience and knowledge. And then I just tell everyone on the team and outside the team, I communicate that this is the decision that was made by me as a DRI, right? It's not a bad way of making decisions per se. So it's one of the ways we can make decisions in our toolbox, but it's also like super fast occasionally. That's why it can be reasonable in some cases, but there are some different ways. And second is the consult and decide model. So the DRI would reach out to domain owners or people who know this area the best, and he will make enough consultation with them. He will ask for their review, for their input, and at some point he stop and like give a call. So he will decide how we proceed based on these consultations. Third option is just to delegate. So DRI itself, himself or herself, doesn't decide and just tells, okay, this is you now responsible to make those decisions, and then actually this person have these 4 options again. And fourth option to make decisions is to just try to get a consensus among the whole team or all the stakeholders. And as you may imagine, this can become a very slow and maybe not so accountable process. So we will not know who made this decision later. And the behaviors DRI should be focusing on it's summarized in this table. So first, of course, we want to him to consult with right people, and the thing that we want to avoid that DRI will not consult with anyone. It's just like decide just based on his limited experience. Then good DRI will surface the best ideas from everywhere, even if whoever, like a person or a client or junior or team lead had this idea, then the good DRI, and if it's really the good idea, then DRI will give credit and surface this idea. And bad DRI basically will hoard information and will try to control also information flow in a way that he somehow maintain this bottleneck of information going through him. Also, good DRI will make great decisions fast. It's not. It's very important both to make great decisions and also not to make them very slow. And one way to prevent making slow decisions is trying to not trying to please everyone, because in this case, if you try to please everyone, probably just 2 people who disagree on your team, and you will spend a week just trying to sort of find a consensus between their ideas. Also, very important to communicate decisions clearly and persuasively. And that's the whole different topic of how to communicate and what soft skills to grow to be able to communicate your decisions clearly. Then if you cannot do that, obviously one way is to just dictate decisions without reasons, and that's nope column I'm looking at currently. Then good DRI will make mistake, correct them, and learn. Hopefully not many mistakes, but when he makes mistakes, he admits and tries to investigate them, make root cause analysis, and find a way how to prevent them in the future. Bad DRI will not bring the team along. Good DRI will personally own results of his actions or whatever results which came out of this team journey on the project. So it can be also actions of different people using our product. Bad DRI will frequently make bad decisions, self-explanatory, and good DRI actually will take calculated risks because actually that occasionally will, like if you don't take risks and you don't calculate those risks before you take them, then either you will move very slowly, or if you don't calculate but you take risks, then obviously something bad might happen. Bad DRI doesn't learn from experience or risk averse, and that's what I was talking about, indecisive or defensive. Actually being defensive or super defensive anytime someone says another idea during meeting or on our pull request, on posts a review which asked for a change on a pull request after we spent 2 days developing this great code. If we become too defensive, it might mean that we don't have this growth mindset, this openness to change and to be able to grow and learn. And of course, bad DRI doesn't take accountability. That's why we had this DRI in the first place. And that's how we arrive now at this GitHub's recipe of high performance culture. If I remind you that now we were talking about how, so in GitHub we want to have this very high focus on this triangle of tempo, judgment, and accountability. And in this middle of the triangle, we have DRI, who is responsible and accountable and implements this model of decision of consulting and deciding. Yeah, I think that was it. And I want to share those 3 books, which is to me, very important to develop this culture, to live this culture, to understand it. First one is Hit Refresh by Satya Nadella. And that's about a huge cultural shift he was able to do for Microsoft, because maybe you remember Microsoft before Satya and Microsoft after Satya is 2 different things completely. And you can read, it's also autobiographical. So he tells all kinds of stories about India and cricket games, stuff you don't know probably. And second book is Extreme Ownership wrote by Jocko Willink, like beast of a man, very strong US Navy SEAL, and he knows how to make a Navy SEAL team lead and win, and that's why he wrote this book. And third book I want to recommend is Radical Candor, is actually how to communicate things in clear and persuasive way, but also keeping this mindset of caring for other people, so they will listen actually to what you say. And I think now we are good to questions. I will try to enable my video again if it becomes worth.
Yeah, let's try.
Okay. Can you see me now?
Yeah.
Okay, I hope it's still good performance. I can see my battery is like 5%, so probably I used all my resources.
Yeah, you put all your energy to this report. Thank you.
Yes, your presentations was really excellent. And I think that the list of books you shared with us, we will take it into our account and read after maybe this event or maybe free time. So now let's try to answer the questions from the audience. We have a lot of them.
Yeah, we have a lot of questions. And the first one is, HPC looks very similar to the agile approach. How do you think what distinguishes HPC from agile?
I mean, agile is a lot of different things, right? So for HPC or highest performance culture, I don't think we branded this somehow with GitHub. Okay, so how agile is different from HPC? I don't think like that GitHub somehow branded or this HPC concept. It was just, to my knowledge, something that out of all different tools we have, Agile, Scrum, whatever, leadership practices, it was just something that combined this recipe for us to focus on at our stage and to improve our culture at this point of time, as I understand that. So it's like more narrow thing that focuses on our current state in GitHub and what we want to develop, which capacities we want to grow to be able to continue creating these great products.
Mm-hmm. Okay, thank you.
Hope it answers the question.
Yeah, makes sense. Have you faced a professional burnout in your team?
Shall I proceed with questions myself? I can read them also.
Let me ask you. Have you faced a professional burnout in your teams? How do you deal with it?
Good question.
I hope you haven't burned out.
Okay, that's an interesting question because, yeah, right. One of the points of is, yeah, sorry, yeah, I still have some delay, so I will try to answer this as one block. So burnout topic, I think it's more important to leaders and to HRs on one side, but also I'm like individual contributor. So maintaining my own personal state of satisfaction and ability to perform is also super important. I mean, I'm a normal person, so ups and downs, and sometimes it was because of a lot of things that we did, and we tried to move faster than we could, and then we had to step back and what happened in the world or like outside of my work area, which job. So in this way, actually in Microsoft we have and in GitHub we have this what is called a psychological safety idea. So we maintain this ability to also reach out to our leadership and to our manager and talk to them and tell them, okay, that's how I feel at the moment. And we have actually a lot of tools to say or to tell other colleagues that we don't feel well today, like we got this code, or like we spent a week building this product and we just want to have like a little bit easy next week because of high volume of tasks previously. So it's normal to be aware of that. It's normal to be able to talk that to your peers and to your manager. And if you cannot, maybe it's good to look why. So good communication channel, good exchange with your manager, I think is super important to maintain this state of not burning out. And if you feel like you're burning, you should raise and like speak up and tell and find a ways, like take a vacation, something like that.
Yeah, thanks for sharing with us. The next question, how do you recognize a good performer on an interview?
Good question. So yeah, I'm doing personally job interviews, not during the last year, because if you heard, like we stopped hiring in GitHub and Microsoft. So I didn't do any job interviews recently. Yeah, I mean, first I would check his resume. What did he manage to achieve? And then I would ask him about some projects which would be most interesting to me. Like what was his role on this project, and what was his job to make this project succeed. And then I would dig a little bit into this interview process, because like usually people at first they start to answer generally, like my team did such and such, and like we'll describe features. But then you want to focus them to make them talk about what did you specifically do for this project, like what did you like to accomplish on this project, was your wow moment when you shipped it, like what did you like when it was shipped. So you would dig deeper into his personal involvement with this project, and then this way you know if he was actually involved, and if he was actually if he contributed to success of this project, if he is aware what is the success of this project, if he just like wrote some code and then someone else was shipping it, and then customer support was getting a lot of tickets and he was just not aware about that, or he was like responsible for the whole process, including support escalations and talking to customers later and supporting this feature in production. So yeah, like diving deeper during the interview process into one or two areas of what person thinks was his favorite moment on this project.
Mm-hmm. Great. And I think the last question, what best practices can we use, can we follow to ensure that we are effectively using fail-fast methods to deliver software quickly while maintaining quality?
Mm-hmm. Which practices?
Mm-hmm.
Okay, yeah, good question. I think like there are multiple practices you want to implement. First is safe deployment practices, that when you deploy, you have stages before you reach production, that you able to test your product incrementally. First with your CI, second is in your test environment, and third, in keep monitoring the same feature or a small improvement later in production. So for that, you have to have enough visibility on every step. So you have to have enough visibility for your tests, for your deployment in staging environment, and also after you deploy to production. So a lot of monitoring, a lot of visibility, good dashboards for telling you meaningful stuff, and not just like random metrics, but something more customer-oriented metrics to tell you what customer experience is for this feature. And yeah, as I said, like if you realize that you it takes long time for you to ship to get to desired quality, then maybe you need to split and to minimize the set of features you want to ship with this release. So next time you try to make the feature smaller, and then you improve it, you polish it, and then you ship it. So good CI/CD, fast CI/CD is very important. And it's also from Accelerate book, right? So you want to ship as fast as possible. So when your deployment pipeline is trained and fast, you do it every day, then even if you ship something bad, some small bug, then you can very fast roll back and deploy fix. Yeah, GitHub, we ship like 20 times per day, I think, different improvements. So it's very high velocity for this huge product.
Yeah, thank you. I hope that your answers have satisfied the questionnaires. If you have questions for Yuri, please feel free to write them down in our chat. So let's choose the best questions from your opinion.
Yes, I think burnout question is very important. So please, I mean, be aware and don't let yourself burning out. So you should be aware to care about your own state, and yeah, develop this good ability to talk to your manager, to your peers, to your colleagues about that.
Yeah, thank you. Thank you, Yuri, for sharing your experience with us. See you.
Thanks for having me, and I'll stop sharing.
Yeah. And now we have our next speaker, Andrey. He's a manager and a team leader, software engineer with more than 8 years of experience. In his talk, he will show us how to use Nest.js, a framework built on top of Node.js, and apply clean architecture principles in TypeScript to create a maintainable and scalable code base. Let's dive deep into Nest.js with Andrey.
Hi guys. Yeah, thank you, Gleb, for introduction. And yeah, I'll share my screen pretty quick. And yeah, okay. Well, yeah, I want to talk about the clean Node.js application architecture with TypeScript. But before we start, actually, I have a question to all of you guys, like to all viewers of this conference. So, if you can open scan the QR codes, open menti.com and answer just one simple question. What is the biggest problem or problems in your project's application on your like a day-to-day work, or if you're studying like a what do you think about it? So you can provide multiple answers. That's okay. But yeah, really, I'm really curious to see the results. Yeah. Okay, we have 20 participants now. Great. Okay, bad management, legacy. Great. Big. Interesting what? Layers leakage. Yeah. Okay, let's have a couple like a minutes. Okay, distributed monolith. Yeah, no problems. That's a happy man. I'm like a yeah, proud of it. Okay. Right now the legacy area growing. Yes. Okay. Release process, accountability, unclear feature requests. Yeah, fair enough. Okay. People. Maybe like if the people problem, like it's a good time to change the company. All right. So this is great. This is great. And yeah, I see that's like the biggest part here is actually legacy. And yeah, actually, let me be fair with you. We also had the same problem with legacy and multiplication in our company. And yeah, just like answer yourself like several questions. Like if you have like legacy parts in your work, and if you really need to write new features in legacy parts of your application, and if you're really sick of it, that's a definitely presentation for you. If not, yeah, like I also like it. We'll also like want to talk about the clean architecture in general, and yeah, let's speak quickly about like our case that we had in our company. So we have like several services. Some of the services created a long time ago. Some services like a newer one. We have a monolithic part. We have microservice part. So it's like a really pretty big um, creations of tools and technologies. And for the new features in several areas, we still need to write code in legacy. While in meanwhile in the other parts, we can use the newest technologies like Nest.js. And yeah, that was like a big problem for us. And I think that's we found a good way, and that's how we run in application production for almost a year. And I can tell that was successful approach. So yeah, like a quick um, quick plan, like what we are going to talk about today. Like what is a clean architecture? Yeah, like a theoretical part. Clean architecture implementation in Nest.js with the small examples. And yeah, what to do if there is no Nest.js application, Nest.js in your application, but you really want to refresh your architecture? Well, kind of boring part, but that's important. Yeah, some of you like might ask that, hey, Andrey, do you really want to talk about the some architectural concept created at what 2012? Well, yeah. So it's not a big surprise that some of these some of these concepts are still valid. And yeah, let's just look at this diagram pretty quick. We will dive to the concrete example later, but what is this diagram? First of all, it's layers. So each ring represents an isolated layer in the application. Then we have dependency. So dependency direction from outside in, and we have entities. Like a entities, that's a place where you should have all of the business entities that construct application. Then we have use cases. This is where we want to centralize our logic, and each use case orchestrates all of the logic for a specific business use case. For example, adding new customer to the system. Then we have controllers and presenters. So like our controllers, presenters, gateway are intermediate layers. So you can think of them as an entry and exit gates to your use cases. Then we have frameworks. So this layer contains all the specific implementation, like a database, web frameworks, error handling frameworks, and so on. I really love this phrase. That's like how Robert C. Martin described it. So this layer is where all the details go. The web is detailed, the database detail. We keep those things on the outside, where they can do little harm. Okay, actually I have another question to you guys. So you can see on this diagram. So can you spot something weird, like something unusual for the classic application, like a classic architecture? So again, I really want to hear your opinion. So you can scan another QR code and answer the question. Like a yeah. So I have I probably already provided several options you to answer. So yeah, just feel free. You can see the picture. This picture here, it's a kind of it should simplify the answer. What is it like a really weird or difference compared to the classic application or even like a monolithic application? So yeah, I don't know. Looks good to me. Yeah, for me as well. But yeah, all right. Let's give a couple of more. Okay, let's wait for a couple more answers, and we'll continue. Okay, so we can see that's like the one option is like a really leading. That's technically DB should be in the core layer for classic application. I'm not even talking about some application that contains like a business logic on database level. It's awful, but yeah, that's happening. Well, yeah, and that's true. So like in this architecture, database is an external when database is usually like in the core layer for the old classic application. And there is a pretty good explanation of that. Well, instead of focusing on the framework, libraries, or like even runtimes, this architecture focus on the business logic of application. So the idea of it is to be framework independent. Yeah, of course, like as much as it can be. So it doesn't matter like which database framework or even external like a service you're using. So internal layers of the application will stay the same, even if you decide to change the database or replace one service to another. So this also makes it easy to test applications that are built with this architecture. All right. Well, yeah, like a last part of the theory, I promise. And I want to talk with you about like a clean or like a architecture implementation with the Nest.js. So yeah, like this is information from literally from the Nest.js documentation. I don't want to read all of it, but I just want to highlight several things from here. So Nest.js was created to effectively solve the main problem of a different Node.js project. And yeah, like no surprise, this problem is architecture. And Nest provides out-of-box application architecture, which allows developers and teams to create highly testable, scalable, loosely coupled, and easy maintainable application. Well, again, it's not a secret, but Nest.js developers and Nest.js application heavily inspired by Angular. Well, let's go to the a bit more practical part. So if you're creating your application from scratch, you literally need to execute several commands. You need to install Nest.js CLI, and you just need to tell Nest.js to create new project. Yeah, let's go to the small demo. Okay. So this is literally the results of the executing the command that I showed you on the previous slides, like a Nest's new application name. And yeah, what we can see here. So we can see the model, we can see controllers, we can see the tests, like including the event tests for different parts of application. Yeah, that's great, but let's try to do something better. So yeah, this is just a base model, it's a base application. But what if I want to create a new feature in in this application? So what I can do? I can type nest generate resource like a features, like all features with all of the tests and all of the stuff. It's a resource in Nest.js, and this like a resource with the name users. Let's hit enter. Let's wait a bit. Let's allow Nest.js to think and scan our application folder structure to start the wizard that allow us to add a new feature to our application. All right. So waiting a bit. That's like a, yeah. And what we can like choose here. So yeah, that's just telling us like, okay, which transport layer do you use? Like it's maybe like a REST API, GraphQL, microservices, WebSockets. Okay, for our application, like a simple example, let's do REST API. Would you like to generate, create, read, update, delete, and entry points? Yeah, sure, why not? Okay, and it's like doing some magic. It's also installing npm packages, and as a result, we should see new feature generated. So what's happened actually? Right now, we can see the new folder named users. So that was the name of our feature. And this folder contains controllers, service, entities, like a database, like a DTOs. And also in the changes, we can find that it's also like a change the root file up module. Yeah, it's actually like in the up module, it's already registered our new feature here automatically. Just think about it. How cool is that? In that way, I can generate applications inside the monorepo library, classes, controllers, decorators, and many, many more. Just I like highly recommend you to check Nest.js generator documentation. So literally, if you want to add new feature to your application, you just tell Nest.js to do that. Yeah, like let's actually take a look at like a what inside. Yeah, but actually, like I have another tiny quiz. So like a previous screenshots, like a previous slide is still valid, and I have a small question to you again, so you can scan the QR code here, and yeah, I can reveal the question right now actually. So, do you remember what were the two core layers of the application according to the clean architecture concepts? So let's wait for a couple of more people and we'll start the quiz. Okay, 9, one more. Okay. Okay. I will start the tiny quiz. Don't worry, like we will see the details on the next slide with the QR code. Yeah. And like you have a kind of like a 1 minute to answer. So what do you think? Do you remember what were the two core layers of application? Database and entities, gateways and use cases, controllers and entities, or entities and use cases? We have 9 answers already, 10, 11. Try to not use Google. So like this is not the something that's will like celebrate someone like who won this quiz. It's just like there was small entertainment part. Yeah, like entities use cases. That's correct. And going back to our example, actually, so what we can see here. So we have our entities, like in the separate folder. Yeah, it's currently empty because yeah, that was just generated by Nest.js. And technically, like an entities layer, it should contain all of the business entities that construct our application. Then we have like this folder, DTOs, where we have like a create user DTO, update user DTO, currently like empty, but yeah. And this is our use case layer. So this contains all of the business scenarios that your application supports, actually. Then like all of the technical details, configuration, implementation, it's right there. Like we have our entry point, we have like our controller, we have our module, we have our service. Yeah, so everything is here. And yeah, actually, what we can see here, so we can find that we can find the module that's which is responsible to one actor. We can find like extensible classes. We can find like interfaces and the entity separation, and we can even find dependencies via abstractions. Sounds familiar, yeah? So again, tiny quiz. So what is that? Like a module responsible to one actor, extensible classes, interfaces, entity separation, and dependency via abstraction. I can like add one tip. So like it's just a one word, or to be clear, it's like a acronym. Okay, let's wait for a couple answers. I'm just curious, like how people can recognize that. Okay. Okay, let's wait for 10 answers and reveal. Not a big secret, but yeah. All right, 5 answers yet. Couple more. 6. Waiting for 10 and revealing the answer. And you can just test yourself, like yeah. Okay. Pressing enter and yeah, actually, like we have several answers, like a solid, and yes, that's a clearly the implementation of the solid principles. Okay, going back to the slides. I just like show the pretty basic stuff about Nest.js, about like this demo, because the goal of this presentation is not about talk about Nest.js. You can find information about it in the internet. It's like yeah, it's you can find it in the pretty good Nest.js documentation, and yeah. But the more interesting parts like will be a bit later. So just to summarize. Yeah, like some features of Nest.js supports TypeScript, JavaScript. It combines several paradigms like a objective-oriented paradigm, like even the functional one. So it's a modular architecture that simplifies code reuse and maintenance. It simplifies developments with the embedded dependency injection, decorators, controllers, pipes, guards, and so on. And it's also compatible with a pretty large set of the popular libraries. Yeah, and like just several sentences about dependency injection here. So yes, this is a technique that lets you delegate the creation of the dependency to the Nest.js in our case. So in that case, Nest.js runtime, like you can resolve the dependency instead of like you doing it yourself. So in that way, you can write the code that's much more modular, testable, and for sure like reusable. Well, let's go to my favorite part, legacy. Well, yeah, again, it's not a big secret that many developers now recommend Nest.js for use in the new projects. But what about existing applications? Well, I don't think that's any of the managers haven't heard about this cool framework. Will give the green light to rewrite all of the legacy code base instead of like features or bug fixes, just to allow developers to add new code using modern approaches. So trust me, we had the same problem in our company. That's yeah, like a technical project of refactoring legacy monolith application. It's just insane. But developers want to use the new technologies, new tools right now. So that's where we are going right now, like a bit more interesting demo. So we close this one. Okay, so what we can see here. So this is a kind of like a simplified example of the legacy service using legacy application using Express. So we can see the like our service, a legacy service. We can see our like entry points with Express, and like it's a pretty simple. So what you need to do to add Nest.js. This is not something that you can find on the internet right now, but after the presentation, I'll share all the materials, don't worry, and including the link on GitHub with step-by-step instruction. So what you need to do to add Nest.js. So by default, unfortunately, Nest.js is not supporting adding adding new parts to legacy applications, to existing applications. So Nest.js generator is not working in the like a super smart way to mix legacy and the new architecture. So we need to do like several manual steps. So first of all, we need to rename our original package JSON file. So we need it later. So let's rename it like a package all JSON file. Then like a it's optional, but just to not mix all the new codes, I recommend to actually rename the source folder to something like a src legacy. And yeah, that's Visual Studio Code to rename imports. Well, also like in our application, I have ESLint config. I don't actually need it because Nest.js will generate own config. So then like then we are going to a point where all of the magic happening. I'm executing the commands nest new. I'm telling this generate a new project inside the current folder, skip git initialization because we already have a repository. Skip, then like I'm telling like skip package installation because in that case we might have a conflict with the package log file. It's also like a generated, and yeah, also telling that like please use npm and as a language use TypeScript. Our legacy application, remember that our legacy application is using just a JavaScript, not TypeScript. So after that commands, what I need to do? So in my application, it's pretty simple. So I don't have any kind of dependency in this example in all application except Express. So by default, Nest.js also using Express. So I don't need to mix dependency manually. But for your application, yes, you need just copy paste dependencies from old package.json file to the new one, and yeah, probably resolve conflicts if any. All right, so let's Nest.js to let's send like npm to install all of the dependency that's came with Nest. And yeah, remember that's our application, our legacy application. It's just a JavaScript that's using just Node to start. Nest is using TypeScript. That's what we choose at the beginning. So we need to change the start comments because I want to keep my old entry points. I still want to start my legacy application. So how can we do that? Well, for that scenario, I just need to replace the start comments. So yeah, these start comments, I'll just keep it simple. I'll just replace it in that way. Yeah, and because it's like a TypeScript, but I want to use JavaScript as well, like in legacy parts. I don't want to touch legacy at all. So the idea is here that we can inject new technologies to legacy application, start writing features in new part of application, and even possibly write some old features. Okay, so to do that, to mix the codes and allow JavaScript, I literally just need to change the compiler options of the TypeScript config to allow JavaScript. Well, that's literally it for this part. I mean, okay, right now what we can see, we have our application that's still starting legacy. So even using JSON, but it's starting legacy part using Express, and nothing unusual here. So right now we just need to teach Nest.js to work with our legacy code somehow. So for that purpose, we just open in the source folder. We are going to main file, and here you can see that's a main file. That's that was our entry points of the Nest.js application. We don't want Nest to start our application actually. So what we want to do? First of all, let's change our import. So remember that's our legacy application using Express. So let's add the Express adapter just explicitly, and let's change our bootstrap function. So right now our bootstrap function literally starts an application, like a create application starting it. I don't need it here, so instead of that, we'll just tell that, okay, bootstrap function, let's use the express that came outside, wrap it to the Nest.js express adapter, initialize create application and slice it, and just return it. But do not start it here. Okay, just for this demo, I prefer to change the controller actually here. So instead of just a I do it like a main controller. So our new part of the codes, our Nest.js codes, all of the methods here will be accessible under the v2. Okay. Then we need to go to our main file, to our entry points, and oh yeah, we right now choose the TypeScript, and we choose the we change the compiler options a bit. So Express needs to be imported in that way right now. And yeah, we have our old legacy service on the v1 endpoints. Let's import our bootstrap function actually. So yes, that was our bootstrap functions from the source main. And what we want to do here? Okay, we are creating Express, we are telling the port, totally fine. We have our v1 endpoints, which is also don't need to be changed. And the only one thing that we need to do is to actually start application using Nest.js and wrap existing Express. So literally right now, in the these 5 or 10 minutes, we created the hybrid application. So how it's working? Like we're starting our old application using Express. We are wrapping our Express application to Nest. Then we are starting it on the port that was specified previously by legacy application. Let's test it actually. So npm just run start or npm start. Okay, right now we are waiting to Nest.js wrap our Express and start it. So we'll see the message from the Nest in the console. Yeah, up running on the port. Let's check this actually. Is it really running? Okay, localhost. First of all, let's check the v1 endpoint. It's a legacy. Hi from Express. That's great. And then our v2 endpoints. This is our new code. Hello world. Let's check what is inside the controller. It's using a get hello service. Yes, hello world. So literally right now we executed our legacy application without touching it, really without modifying the legacy code base instead of a folder renaming and combining combining scripts and dependencies. And that's what we can see. Both parts running using the same Express instance, which is important. So it's not a separate application. No, we still can even reuse parts from the legacy when needed, a bot contracts or whatever we want. And yeah, let's actually test in the separate console, for example. What is actually the results? How it's actually compiling all together. So it's just pretty quick. npm run builds. Let's see that's how the Nest and TypeScript combining all together. Okay, so this folder is generated. So yes, we have our entry points, source map, we have our legacy service, we have new sources, all compiled all together, and we can start easily application in the production mode also. In the same way, just npm run start in production mode. In that case, we should see everything the same, but a bit quicker in production mode. V2, V1, all working. Well, guys, that's actually literally it. And just in conclusion, I want to say, just don't be afraid of new technologies, even on the old projects. Just always look for options on how to make your work easier, because as you know, progress is made by a lazy man looking for easier ways to do things. Here you can find the links. Here you can find the links on the official Nest.js documentation. It's read it. Just try to read it. Here you can find this article from where I started about clean architecture, and here's the link on the GitHub with the example, and QR codes also pointing to the GitHub, where you can find example step-by-step instruction how to include Nest and modern application to your legacy parts. And here's my LinkedIn. Well, I hope that's right now you guys you have a bit more confidence, and that's something that you can sell to your managers, because yeah, if you really need to work with legacy or want to try new technologies in a bit more in the a bit more safe way than just a big refactoring, that might be a good solution for you. Thank you. Okay, questions?
Yeah. Andrey, thank you for sharing your expertise with us. I hope everyone are interested in that and maybe will use it in their job. So let me see the questions. The first one is this architecture good to share some pieces of code with the client part executed in a browser?
Well, technically, yes, because no one prevents you to use the code generation and contract generation to be clear, that's actually how we're using it in our product. So we're actually generating the contracts from our business logic part, literally from the let me open the previous example. Because remember that's like from where we started, that this architecture is independent and we have our entities here. Like it's independent. It's a framework independent. It's just like a pure TypeScript in that case. So we can easily reuse and generate some contracts and share some code contracts between client and server side. Okay.
Okay. Let me ask other question. What happens if the endpoints have the same name in Express and Next?
Okay. Good question. In the example that I showed right here, we are wrapping actually Nest, we're wrapping Express inside a Nest application. So in this example, yes, Express wins. We can easily check it. So for example, let's do the V2 endpoints for both parts for legacy and Nest. So let me change, let me execute npm run links. I believe it's a line endings. I just hate to see some red parts in my application. Sorry. Okay. Anyway, let's start it. npm run start or just npm start. So right now what we can see, v2 for legacy, v2 for Nest. Because we are using Nest as a wrapper for the Express, we should see that's our v2 endpoints returning high from Express all of the time. It's not even the race condition, so it's stable. So yeah, this is the reality, and actually there are other ways how to use a Nest.js within legacy, and you can use it as the middleware, for example, even for your GraphQL applications or a REST applications, doesn't really matter. In that case, you can configure it in that way. That's Nest wins. So you can rewrite new features, rewrite old features in the using new codes, using new technologies. And in that case, a Nest.js endpoints will rewrite legacy. But for the easiest and the classic example how to integrate it, yes, Express wins.
Okay. What is the learning curve for Nest.js compared to Express?
Well, I can tell that it's I can tell that it's a big, because Express, it's not something that's it's not a full architecture. So Express, it's a framework. For the Nest, it's even better. So it's a full framework where it's it generates a lot of things for you. That's what I showed that's in the previous examples. That's it's also creating the test. It's a pre-creating stuff for you. That's why it's pretty easy to learn Nest.js. It's it's because it's a clean architecture, literally. So you can it's pretty structured, and you can easily understand what's happening with the application, what's how to generate new features, how to work with that. And another thing it's just a really great documentation for the Nest.js. Probably you don't even need to complete some online courses to learn it. You can just read documentation. And it's a pretty clean and pretty understandable with a lot of examples on different use cases. And again, it's a pretty popular framework. It's for the modern application, it's becoming an industry standard right now. So that's why you can easily find the answers on the internet if you're just struggling with something. Yeah. So long story short, it's more than just framework comparing to the Express. That's why it's a bit complicated, because it's just a much more thing that's you need to understand, but it's pretty easy to understand comparing to the other types of the frameworks or architectures? Yeah, I will tell it. I will answer it in that way.
Great. So, Andrey, thank you so much for this presentation and for answering our questions. Please choose the best question among that I asked you.
I like a question about the sharing contract because, yeah, that's important thing. That's sort of like a philosophy of the clean architecture. That's these two layers are independent and it can be shared not only like with the server-side code that's like I mentioned, but even with the client side.
Yeah, agree with you. Great question. Thank you so much, Andrey.
Yeah, thank you.
Yeah.
So thank you very much. My dear friends, we're coming to the end, and it was our last speaker. So before we finish, I want to remind you one more time that the video of the conference will be posted on our YouTube channel, Akvelon.it, and on our landing as well. So the links along with presentations from the speakers will send to your email addresses provided during registration, and will send a guide and survey on how it went. So that's why please check your email addresses.
Yeah, I think we had a very amazing conference. Thank you to all of you. Thank you, our speakers. Thank you, our attendees. We learned how to optimize our development skills and boost productivity through various innovative approaches. We hope you enjoyed the conference and gained valuable insights to apply it in your work. See you next time. Thank you.
Yes. Thank you very much for sharing your thoughts and ideas and presentation your lectures. And I hope that next year we'll see again and know and learn something new from you. And I wish you good weekends and see you next time. Goodbye.
Bye.